October 21st, 2025. While you were scrolling through your feed, eating breakfast, or maybe asleep on the far side of the world, something without precedent took place. The National Aeronautics and Space Administration quietly activated its planetary defense network. Not for an asteroid, not for a near-Earth object we have monitored for years. It was for an interstellar visitor, something that does not belong to our solar system. For the first time in recorded history, the International Asteroid Warning Network, the same coordination framework built to protect humanity from extinction-level impacts, powered up its global array of telescopes and directed every available instrument toward a single, uninvited guest, 3I Atlas, the comet that should not exist here. You might assume an event like this would flood headlines, dominate news cycles, and spark endless debates. Yet it unfolded in silence. There was no press conference, no dramatic statement. Instead, at exactly 21 hours and 8 minutes Universal Time, a single document quietly appeared on the Minor Planet Center's website. Bulletin 2025 U-142. 16 lines of text, buried beneath dense scientific jargon few people would ever notice. It was labeled as an editorial notice, announcing an astrometry campaign, a phrase that sounds painfully mundane, clinical, forgettable. Except for one detail that shifts everything we think we know. The target is listed as 3I Atlas, identified explicitly as an interstellar object. And the organization running the operation? The International Asteroid Warning Network, the very backbone of planetary defense. Before we continue, let me pause to address you directly. Hit the like button, subscribe to this channel, and let us know in the comments where you are watching from, what time it is there, and tell me honestly, does any of this feel like a cover story to you? Help this community grow by sharing the video and tapping that hype button below. Thank you for your support. Now, let us be clear about what the International Asteroid Warning Network actually is. This is not an amateur astronomy club. This is not a gathering of hobbyists with backyard telescopes and coffee. IA-1, as it is known, forms the operational core of planetary defense. When a new asteroid is discovered on a potential collision course with Earth, this is the organization that coordinates the global response. They synchronize telescopic observations across continents, calculate probabilities of impact, and provide guidance to governments on what actions to take. They are the people who would tell us if we needed to evacuate cities, or even launch missions to deflect an incoming object. Their mission statement is as simple as it is terrifying. Find the threats, track the threats, and give humanity enough time to act. Their test cases are never trivial. They practice coordination on bodies that matter, potential hazards, anomalies, objects of high interest, not routine comets, not harmless wanderers, targets that could redefine our understanding of what is safe and what is not. And now, for the very first time, they have mobilized for something that came from beyond our solar system. A visitor that, according to every official statement, poses zero danger to Earth. A visitor that will not come within 270 million kilometers of our planet. And that, precisely, is the detail that should make you pause. Because it does not add up. The bulletin itself is a masterclass in understatement. It declares an observational campaign beginning on November 27th, 2025, and ending on January 27th, 2026. The stated goal is to introduce methods for improving astrometry from comet observations. In other words, to train astronomers to measure a moving target more accurately. They present it as a workshop, a calibration exercise, a global opportunity to practice on a particularly tricky comet. The technical justification sounds entirely reasonable. Cometary bodies, the notice explains, are extended objects with diffuse halos, coma and tails, that can distort centroid readings and pull measurements away from their true centers of brightness. That is standard textbook science. It sounds methodical, grounded, and perfectly legitimate. Except for one extraordinary issue. 3I Atlas does not behave like the comets they describe. Its photometric center, the point where its visible light appears strongest, does not align with its predicted orbital path. The light and the mass are not in the same place. That is the anomaly buried in the fine print. That is the mystery they are quietly trying to solve. And it is not new. Astronomers in academic circles have whispered about it for months. An object whose luminosity does not match its motion. A celestial body that seems to shine from the wrong location. Now, consider the schedule they have outlined. The observation campaign does not begin immediately. It starts on November 27th. Why wait? Because 3I Atlas reaches perihelion, its closest point to the Sun, on October 29th. After that, it spends nearly a month lost in the blinding glare of the Sun, impossible to track with Earth-based instruments. Only when it emerges again, visible against the dark of space, does the campaign begin. The timing is precise. A preparatory workshop on November 10th. A kickoff meeting on November 25th. The observation window opens November 27th. A mid-campaign check-in on December 9th. The program concludes January 27th. Every step seems planned to the hour, as though they already know exactly what they expect to find once the comet reappears from behind the Sun. A place where, for several weeks, no human eyes can follow it. Closeout teleconference on February 3rd. That is not how you wrap up a casual training workshop. That is how you close a multinational surveillance operation. Every step of this so-called campaign carries the signature of coordination on a planetary scale. The kind of operation designed to ensure that every major observatory on Earth is watching the same object at the same time, collecting synchronized streams of data and feeding them into a shared analysis pipeline. And here is where things become truly intriguing. The workshop scheduled for November 10th is not open to everyone. It requires registration, and only those who complete it can participate in the official campaign. In other words, they are pre-selecting the observers. They are screening participants to make sure every astronomer involved knows the precise protocols, data formats, and reporting methods. This is not an open exercise. It is a controlled experiment. They are forming a vetted circle of professionals, a trusted inner network, who will all be observing 3I Atlas during its closest approach to Earth in December. Registration closed on November 7th, 2 full weeks ago. The roster of participants has not been released. We do not know which observatories are taking part, which telescopes have been reassigned, what sensors are being deployed, or what type of data is being prioritized. The only fact we have is that by December 19th, when 3I Atlas makes its closest pass to Earth, the entire planetary defense network will be simultaneously watching. systematically, methodically, without public attention. Now, let us unpack what astrometry actually means in this context, because the term is often used without understanding its significance. Astrometry is the science of measuring the exact position and motion of celestial bodies. For comets and asteroids, precision astrometry tells scientists not only where the object is, but where it has been and, most critically, where it is heading. From these measurements, one can compute its orbit with extraordinary accuracy, forecasting encounters with Earth years or even decades into the future. It is the backbone of planetary defense. When NASA and the International Asteroid Warning Network say they are refining astrometry for 3F near Atlas, what they are really admitting is that the current orbital data is insufficient. The trajectory is uncertain. The predictions contain too much error. And that raises a simple but unsettling question. Why would uncertainty matter if the object poses no threat? You do not need millimeter-level precision for a comet expected to pass at nearly twice Earth's distance from the Sun. Unless you are worried it might not pass us after all. Unless you are concerned that something could shift its orbit. Unless you suspect forces might act on it during perihelion, its moment of closest approach to the Sun. That is where the Oberth effect enters the conversation. The principle, well known in astronautics, states that the most efficient point to alter a spacecraft's trajectory is at perihelion, the moment it is moving fastest, deep within the Sun's gravitational well. A small thrust applied at that point can produce an enormous change in the final orbit. If an object wanted to decelerate from interstellar speed and settle into a stable orbit around the Sun, perihelion would be the perfect place to do it. And for 3F Atlas, that moment occurs on October 29th, precisely 8 days after it disappears behind the Sun, hidden from every Earth-based instrument. 8 days of total invisibility in which any maneuver, natural or otherwise, could take place unseen. I am not declaring that 3R8 LOS is performing an Oberth maneuver. I am saying that NASA is coordinating a 2-month global observation campaign timed exactly to detect the aftermath of such a maneuver should it occur. They are mobilizing the Planetary Defense Network to monitor potential changes in trajectory, irregular outgassing, or fragmentation patterns that could signal something other than ordinary cometary physics. The precision of the schedule is too sharp to be random, and they are not concealing any of this. The bulletin is freely accessible online. Anyone can read it, though few will. It is written in the dull, labyrinthine language of bureaucracy and science administration, so dry that it repels attention. This is transparency used as camouflage, truth hidden in plain sight by being too tedious for anyone outside the field to care. Yet one final phrase in the bulletin stands out. It states that cometary bodies pose unique challenges for astrometric accuracy. True enough. But then adds that 3EA Atlas will be used to exercise the capability of the observing community. Not accuracy, not precision, capability. The word choice matters. Capability implies preparation, the ability to respond, to act when needed. It is not a test of instruments. It is a test of readiness. The capacity to coordinate a global observation campaign on almost no notice. the readiness to track a rapidly moving interstellar object as it sweeps through shifting constellations and regions of the sky. That is what this operation truly demonstrates. They call it a drill, but it is a drill using a live target, a rehearsal carried out on something real. It is practice for the day when we discover an interstellar object that genuinely poses a danger. Or perhaps it is not practice at all. Perhaps it is the response to something that has already triggered every internal alarm, disguised in the language of a training exercise to maintain calm while they determine what exactly they are dealing with. Consider what happened during the Mars flyby. On October 3rd, 3I Atlas passed within 30 million kilometers of Mars. Several spacecraft were positioned to observe it. The Mars Reconnaissance Orbiter, armed with the high-resolution imaging science experiment camera, capable of resolving features smaller than 30 kilometers per pixel. The ExoMars Trace Gas Orbiter, equipped with its color and stereo surface imaging system, Mars Express with its high-resolution stereo camera and Omega spectrometer. Even the rovers on the surface, Perseverance and Curiosity, were instructed to aim their cameras toward the Martian sky. The European Space Agency released a few faint, distant images from the encounter. The comet appearing as a tiny smudge of light against a backdrop of stars, precisely what one would expect from an object hurtling through space at that distance. But the National Aeronautics and Space Administration has released nothing. No images from the high-resolution imaging science experiment, no spectroscopic data, no press release celebrating this rare, once-in-a-lifetime chance to study an interstellar visitor from multiple vantage points. The silence is deafening. The high-resolution imaging science experiment is one of the most capable cameras ever sent beyond Earth. It can capture details smaller than a dining table from orbit. At 30 million kilometers, it should have produced the clearest, most revealing images of 3I Atlas ever taken. Images that could determine the size of its nucleus, the structure of its coma, the behavior of any jets or outgassing. Data that could answer basic questions about what this object truly is. Those images exist. They were taken. The data was transmitted back to Earth. And yet, none of it has been shared. Not with the public, not with the broader scientific community, not even as preliminary findings. There are two plausible explanations. Either the images revealed nothing noteworthy, and the delay is simply bureaucratic inertia, which would be strange given the immense public fascination with this event. Or the images revealed something that demands analysis, coordination, and discretion before any announcement can be made. Something anomalous, something that changes the narrative of what 3I Atlas might represent. And now, less than 3 weeks after that silent Mars flyby, the International Asteroid Warning Network activates. The Planetary Defense Network spins into motion. The Global Astrometry Campaign is announced, with workshop prerequisites, closed registration, and a 2-month observation window aligned precisely with the object's closest approach to Earth. You do not mobilize a planetary defense infrastructure for a routine comet. You do not activate the global surveillance grid for a harmless visitor from beyond the stars. You do that when you need every telescope on Earth watching the same object, collecting identical data, prepared to react if something changes. You do that when you suspect the object might not obey its expected path. You do that when you are preparing for scenarios not yet ready for public disclosure. The document that triggered it all ends with a bland bureaucratic closure. Minor Planet Center Staff. Copyright 2025, Minor Planet Center. No dramatic phrasing, no implications, just another day's entry in an endless catalog of orbital bulletins, except this one is different. This one activates a global defense network that has never before been activated for an interstellar object. This one organizes a synchronized campaign to monitor a body officially declared harmless. This one schedules its observation window precisely at the time when any deviation from a gravitational orbit could first be detected. Right now, 3i Atlas is hidden behind the sun, invisible to ground-based telescopes, racing through perihelion at over 68 kilometers per second, bathed in solar radiation intense enough to trigger outgassing, fragmentation, or structural change, located at the perfect point in its journey for any form of propulsive maneuver, natural or otherwise. And in roughly 40 days, when it emerges from the solar glare, every eye of the planetary defense network will be fixed upon it. Every observatory, every participating astronomer, every instrument capable of following a fast-moving light across the pre-dawn horizon. They are not telling us to panic. They are not warning us to prepare. They are calling it an astrometry exercise, a technical workshop, a chance to refine measurement techniques. And perhaps that is exactly what it is. Perhaps the activation of the International Asteroid Warning Network is procedural. The closed registration and careful timing mere coincidence. Perhaps the silence surrounding the Mars flyby images is nothing more than delay in processing. Perhaps there is nothing extraordinary about 3i Atlas. Apart from its interstellar origin, its massive scale, its peculiar spectral signature, its displaced center of brightness, and the remarkable timing of its perihelion passage behind the sun. Or perhaps, just perhaps, they are already observing something that has given them reason to activate planetary defense. Something glimpsed in those unreleased high-resolution imaging science experiment images. Something buried deep in the trajectory data that refuses to align with the existing models. Something significant enough to justify mobilizing the global coordination network and disguising a full-scale surveillance operation beneath the label of an astrometry training exercise. We will know more in December when the observation window opens, when 3i Atlas climbs into the pre-dawn sky, low above the horizon, drifting through the constellation Virgo. Hundreds of telescopes will trace its path each night, measuring its velocity, its brightness, its spectrum, its rotational stability. Streams of data will pour in, analyzed, cross-checked, compared against the predicted orbit. Then we will see whether it behaves as expected, or whether something changed during those silent weeks it spent hidden behind the sun. For now, all that exists is a bulletin. 16 unassuming lines of text, an editorial notice announcing an astrometry campaign, and the quiet, deliberate activation of humanity's planetary defense network for an object declared harmless, for a visitor expected to pass at a safe, distant trajectory, for a comet that, on paper, should not warrant global coordination through the International Asteroid Warning Network. Unless, of course, it is not merely a comet. Unless there is something deeper than the official story admits. Unless someone, somewhere, saw something in the data that convinced them it was time. Time to synchronize the network. Time to prepare a global watch. time to pay very close attention to what comes next. The countdown has already begun. November 27th, the observation window opens. December 19th, closest approach. January 27th, the window closes. Somewhere between those dates, we will discover whether this was simply an exercise or preparation for something far more profound. Chapter 2. The Whistleblower Bombshell. 12 hours after that bulletin appeared, someone broke the silence. Not through an official announcement, not through a peer-reviewed paper or a carefully worded press release, but through a social media post that spread like wildfire, viewed millions of times, and igniting a storm of speculation that no space agency has yet dared to address. A person claiming to be a space debris engineer and analyst at the European Space Agency stepped forward with information they insisted the public deserved to know. Information about 3I Atlas that, if true, would overturn everything we think we understand about this object. The post appeared on Platform X on October 21st, around 1900 hours Universal Time. The account, previously quiet for months, suddenly released a long, technical thread claiming insider access to European Space Agency data and operations that have not been shared with the wider scientific community. The central claim was astonishing. According to this alleged insider, the Fermi Gamma Ray Space Telescope detected a stable emission coming from 3I Atlas in mid-September. Not a transient burst, not a random spike, but a continuous signal that does not correspond to any known natural source in the entire gamma ray catalog. To understand why that is significant, we need to remember what Fermi actually does. The Fermi telescope observes gamma rays, the highest energy form of light in the universe. Natural gamma ray sources include pulsars, black holes, supernova remnants, and active galactic nuclei. Each has a distinct pattern. Pulsars flash rhythmically, black holes flare unpredictably, supernova remnants fade, and active galaxies flicker in complex ways. These signatures are fingerprints that allow scientists to identify their sources. But what Fermi reportedly detected from 3 Atlas matched none of them. The emission was described as stable, constant, and, in the whistleblower's words, not attributable to any other space source. That is not a phrase one uses lightly. It implies every conventional explanation was tested and ruled out. It is the language of someone who has exhausted natural possibilities and found something that does not belong. And then comes the most striking statement. According to the post, the object emits what the source metaphorically described as a steady, engine-like sound. Of course, gamma rays are not sound waves. Space is silent, a vacuum with no medium for vibration, but astronomers often translate electromagnetic signals into sound to illustrate their rhythms. Pulsars become ticking beats. Solar flares sound like static bursts when converted to audio. What this engineer describes is a steady hum, a constant frequency, the kind of unvarying tone one would associate with a machine operating at a fixed power output, something that nature does not typically produce. According to the thread, this discovery occurred in mid-September, roughly 6 weeks before the European Space Agency's own observational data near Mars. And at the same time, other telescopes began noting spectral irregularities in the comet's composition. It was also around the same period when Harvard astrophysicist Avi Loeb began publicly asking whether this object could be more than a comet. Yet, according to the whistleblower, the Fermi data was never distributed through the usual analysis channels. It was flagged, compartmentalized, and restricted to a small, cleared group within the European Space Agency. The author of the post insists they are not seeking fame or martyrdom. They are not terminally ill, not pretending to be someone they are not. They specifically deny all of the usual accusations aimed at anonymous whistleblowers. They claim only that people deserve to know something extraordinary is about to happen. And then they add a timeline. In December, many home-based observers will see it for themselves. December, the same month that 3I Atlas will make its closest approach to Earth. The same month it becomes visible to skilled amateur astronomers with mid-range backyard telescopes. The same period when the International Asteroid Warning Network's observation campaign reaches full momentum. According to the post, that is when whatever is happening with this object will become impossible to dismiss, visible, measurable, undeniable. Now, about credibility. The person remains anonymous. They have provided no name, no employee identification, no verifiable documentation proving their connection to the European Space Agency. The claims cannot be independently verified because the Fermi data in question has not been released publicly. There is no official way to confirm whether such a gamma-ray signature even exists. This could be an elaborate hoax. It could be someone with knowledge of space agency jargon weaving together believable misinformation. It could even be a piece of speculative fiction that spiraled out of control. But what keeps this from being easily dismissed are the details. The technical terminology is accurate. The phrasing is consistent with real European Space Agency protocol. The timeline fits with other observable events, and most notably, the claim that Fermi detected something anomalous aligns uncomfortably well with the silence from official sources. The National Aeronautics and Space Administration has yet to release the high-resolution images from the Mars flyby. The European Space Agency has published only a few low-quality frames from its orbiters. Every institution that observed the object in that period has gone quiet. And silence in science can sometimes speak louder than confirmation. The most powerful instruments humanity possesses have been trained on this object, and yet the highest quality data remains locked away. If the Fermi Gamma Ray Space Telescope truly detected an anomalous emission, that would explain the silence. It would explain the absence of Mars imagery. It would explain why the International Asteroid Warning Network was activated with such urgency. According to the alleged whistleblower, they have been monitoring online discussions about their post. They mention reading threads on Reddit, YouTube, and even the notoriously chaotic boards of 4chan to gauge how the public is reacting. That could mean one of two things. Either this is someone genuinely watching to see how people respond to suppressed information, or it is someone who understands the internet well enough to craft a story tailored for virality. Either way, the effect has been profound. The thread exploded across social media. It has been shared, screenshotted, translated, dissected, and debated across forums, podcasts, and comment sections around the world. Yet so far, every official agency has maintained silence. The National Aeronautics and Space Administration has issued no comment. The European Space Agency has offered no clarification. The Fermi collaboration has released no data relating to 3I Atlas. That silence is, in itself, a statement. If the claims were easily dismissed, a simple denial would have ended the speculation immediately. But when a credible-sounding source makes specific technical assertions about restricted data, and the institutions involved respond with absolute quiet, the silence becomes its own message. There is another disturbing layer here. The whistleblower insists that the Fermi detection was never shared within the European Space Agency's normal research divisions. That implies deliberate compartmentalization, information sequestered, restricted to a handful of individuals with clearance. That is not how science usually works. Under normal circumstances, when an instrument records something unusual, the data is immediately shared with the research team. They analyze it, interpret it, publish it, and debate it openly. Science thrives on transparency. But when discoveries cross into the territory of national security or potential public panic, those open channels close. Data becomes classified. Access becomes need to know. And now, as all of this unfolds, something else happens. Something no one saw coming, except one man. On October 21st, geophysicist Stefan Burns, who has been meticulously tracking 3Phi Atlas since its discovery, posted a message that made even hardened skeptics pause. A massive coronal mass ejection, a CME, had just erupted from the far side of the sun. Not a mild solar flare. Not a passing geomagnetic event. A full halo CME expanding outward in all directions and aligned perfectly with the path of 3I Atlas. A direct hit. Impact predicted within 3 to 4 days, just before perihelion. Burns announced it with exuberance rare among scientists. Boom shakalaka bullseye, written in all caps, his excitement unmistakable. Then he revealed something even more astonishing. He had predicted this months ago. Not just general solar activity, but this specific interaction. That the presence of 3I Atlas would disturb the sun's magnetic environment, provoking electromagnetic disruptions in the inner solar system. The closer it came to the sun, he said, the more intense the effects would be. And now, on the very day of solar conjunction, when the comet was perfectly aligned behind the sun from Earth's perspective, a colossal CME erupted from the far side, aimed straight at it. To understand the magnitude of that event, we must recall what a coronal mass ejection truly is. The sun's corona, its outer atmosphere, is a sea of superheated plasma bound together by tangled magnetic fields. As the sun rotates, those fields twist and strain until occasionally they snap. When they do, billions of tons of charged gas explode into space at speeds ranging from hundreds to thousands of kilometers per second. The ejected plasma carries its own magnetic field, capable of interacting violently with anything it strikes. When a CME collides with Earth, it can generate breathtaking auroras, disrupt power grids, and interfere with satellites. For Earth, the magnetosphere offers some protection. But for a comet, especially one already venting volatile gases into space, the results are dramatic. The CME's magnetic field interacts with the charged particles of the comet's coma, the luminous cloud of gas and dust surrounding its nucleus. It can strip material from the tail, compress one side of the coma, and stretch the other into chaotic plumes. It can, quite literally, reshape the comet in real time. It can trigger sudden brightening as the solar wind pressure spikes. And if the comet possesses any internal structure that reacts to electromagnetic forces, a coronal mass ejection becomes the ultimate stress test. For months, geophysicist Stephen Burns has argued that 3I Atlas is not merely a passive traveler through the solar system. He believes it is actively shaping the electromagnetic environment around it, that as the object heats up and releases charged particles, it creates disturbances that ripple outward, subtly interacting with the sun itself. In Burns's view, 3I Atlas is not just another comet. It is a vast, dynamic generator of plasma and ions. As it approaches the sun, it injects material into the heliospheric current sheet and alters the magnetic field configuration in its vicinity, potentially making solar eruptions more likely. This theory stands far outside mainstream solar physics. Most solar scientists maintain that the sun's activity arises internally, from the slow twisting and release of magnetic energy in its active regions. The notion that a comet, even a large interstellar one, could influence solar behavior from tens of millions of kilometers away is usually dismissed as fringe speculation. Yet Burns has been documenting correlations that he insists cannot be coincidence. In August, when 3Y Atlas was still far from the sun, a sequence of enormous eruptions occurred in the direction of Mars. Eruptions Burns had predicted using his electromagnetic interaction model. And now, in October, during the critical moment of solar conjunction, when 3I Atlas is perfectly aligned behind the sun, another eruption strikes, another direct hit. Another apparent validation of his forecast. The coronal mass ejection itself is extraordinary. Burns describes it as originating from a far side flare, possibly a double-digit X-class event. X-class flares are the most powerful known category, releasing as much energy as billions of nuclear detonations in mere minutes. A flare rated X10 or above occurs perhaps once in a decade. According to Burns, this particular flare erupted on the far side of the sun, invisible from Earth, and its ejected plasma was directed precisely along the trajectory of 3U Atlas as it passed through superior conjunction. Direct observations are impossible. Earth-based solar observatories cannot see the sun's far hemisphere. And our space-based instruments like the Solar Dynamics Observatory are fixed in Earth orbit. Still, the magnitude of the event can be inferred from the velocity and morphology of the ejected cloud. Halo CMEs, those that appear as bright, circular rings expanding around the sun in coronagraph imagery, almost always originate from powerful flares. The fact that this halo event is skewed directly along the comet's trajectory suggests it was launched from a region magnetically aligned with 3I Atlas's path. The timing could not be more critical. The comet reaches perihelion, its closest point to the sun, on October 29th. The CME impact is expected around October 25th or 26th. That leaves roughly 3 days for any interaction effects to unfold before the comet enters its period of maximum solar heating and gravitational stress. If the CME is going to provoke unusual behavior, a sudden fragmentation, a shift in trajectory, or the release of secondary fragments, it would occur in that narrow window, and Earth will not see it. During solar conjunction, the comet is completely hidden behind the sun's glare. Only a handful of spacecraft positioned away from the Earth-Sun line, such as the European Space Agency's Solar Orbiter and NASA's Parker Solar Probe, could potentially capture the event. Yet neither mission has announced plans to observe 3 Atlas during this period. Burns insists this alignment is no accident. He has been predicting this precise sequence since early August. 3I Atlas approaches the Sun. Its plasma emissions intensify. The electromagnetic environment grows unstable. Solar activity surges. Eruptions fire along the comet's line of motion, and as it nears conjunction, the most powerful of all CMEs erupts, striking it directly. Embedded in this scenario is a profound question, almost philosophical in nature. Can a comet influence the Sun? Can a relatively small body, only a few kilometers wide, affect the behavior of a star over 1,000,000 times more massive? In conventional astrophysics, the answer is unequivocally no. The Sun's magnetic and plasma dynamics are governed by processes deep within its convective zone. Surface phenomena, like flares and CMEs, are expressions of that internal turmoil. A comet passing nearby would be, at best, inconsequential. A dust mote drifting past a furnace, a mosquito buzzing near an elephant. Yet Burns is proposing something subtler. Not that 3I Atlas is triggering eruptions through brute gravitational or magnetic force, which would be absurd, but that its plasma output is resonating with the Sun's own fields, modulating them in ways we have not yet learned to quantify. Instead, Burns proposes something far more nuanced. He suggests that the plasma and charged particles pouring from the comet do not directly cause solar eruptions, but act as a kind of cosmic conduit, a channel through which the Sun's existing magnetic energy can escape more readily. Much like a lightning rod does not create lightning, but provides a path of least resistance for electrical discharge. 3I Atlas may be offering the Sun a means to release built-up magnetic tension. In this framework, the comet does not power the flares. It triggers them, creating localized conditions that make eruptions more probable in certain solar regions. There is, in fact, precedent for objects influencing plasma environments. Spacecraft traveling through planetary magnetospheres have been observed to generate electromagnetic waves and accelerate charged particles. Jupiter's volcanic moon, Io, pumps immense streams of ions into its parent planet's magnetic field, fueling auroras so bright they could encircle entire worlds. Even smaller comets passing near the Sun have been known to produce disturbances in the solar wind that ripple outward for millions of kilometers. The notion that an enormous, highly active interstellar comet could shape its surrounding electromagnetic field enough to affect solar dynamics is not impossible, only unproven. But it would require a level of activity far beyond what astronomers typically associate with comets. And that is precisely what Burns and others are seeing. He describes 3Y Atlas as gushing, not outgassing in the ordinary sense, but spewing colossal amounts of water vapor even at distances from the Sun, where most comets remain inert, locked in ice. Observations back this up. Studies published in September reported that 3E Atlas was releasing water at an astonishing rate, described by one researcher as a fire hose, detectable from over 3 astronomical units away. That is remarkable. Most comets do not awaken until they are within 2 astronomical units of the Sun. 3I Atlas began erupting early, and it has not stopped. The amount of water vapor implies a comparable volume of ions. In the solar wind, water molecules are stripped apart into hydrogen and oxygen ions. Those ions interact with magnetic fields, forming structures known as ion tails. Invisible to the eye, but measurable with specialized instruments. If 3I Atlas is generating as much vapor as the data suggests, then it is surrounded by an immense electrically active cloud extending for millions of kilometers, constantly colliding with the solar wind and reshaping the Sun's magnetic boundary in its vicinity. When the coronal mass ejection slams into that ion cloud, the interaction will be violent. The CME's magnetic field will collide with the comet's induced field, producing a phenomenon called magnetic draping. The solar wind's magnetic lines wrap around the obstacle like cloth around a stone, creating turbulence, particle acceleration, and shock waves. For a comet as active as 3/4 Atlas, such an impact could ignite a cascade of visible effects: abrupt brightening, tail disconnection, spectral shifts, even structural stress within the coma itself. If there is any solid core, any denser nucleus, or, as some speculate, any artificial object concealed within, the electromagnetic pressure could reveal its presence. Yet Burns is careful in his wording. He is not claiming 3I Atlas is artificial. He has never suggested it is a spacecraft or engineered probe. What he is documenting is behavior that is extraordinary even by interstellar standards. An object whose activity, emissions, and interactions are measurable, reproducible, and unlike anything we have recorded from previous visitors. And now, at the moment of greatest vulnerability, when 3I Atlas is most active, most volatile, and completely hidden behind the Sun, the star has launched a direct strike. 1 billion tons of magnetized plasma, racing at over 1,000 kilometers per second, is on a collision course with the comet's projected position in just 3 days. What happens when they meet is unknown. No telescope on Earth will see it. All we can do is wait for the aftermath. When 3I Atlas reemerges from solar conjunction in November, astronomers will look for clues. Is it intact or fractured? Is it dimmer, brighter, altered in trajectory? Those answers will determine whether this was merely another natural encounter between comet and Sun, or evidence of something far more consequential. Burns calls it pretty cool to see play out, a modest phrase for a man whose model appears validated with uncanny precision. He forecast months ago that 3I Atlas would stir the Sun to life, peaking near perihelion. Now, as the largest eruption of the cycle unfolds exactly on schedule, coincidence seems an increasingly fragile explanation. If 3I Atlas is truly altering the plasma environment around it, if it is generating disturbances that ripple through the solar wind, then we are witnessing something unprecedented. Ordinary comets only influence their immediate surroundings, and those effects are fleeting, confined to a narrow region of space. What Stephen Burns describes, however, is something far larger. a dynamic feedback loop between the comet's emissions and the sun's magnetic field, a long-term electromagnetic relationship that grows over time and culminates in coordinated solar eruptions at key moments. Yet there may be another dimension to this story. If the local electromagnetic field is being reshaped, if plasma behavior around the comet is abnormal, then instruments such as the Fermi Gamma Ray Space Telescope could indeed detect anomalies. Gamma rays are produced when particles are accelerated to extreme energies in powerful magnetic fields. A coronal mass ejection slamming into the comet's ion cloud could, in theory, create precisely such conditions: shock fronts and reconnection zones capable of accelerating particles to relativistic speeds. Under those circumstances, a brief but stable gamma ray emission could appear, not because of any artificial engine, but because of the raw violence of plasma interacting with plasma. That could explain the alleged Fermi detection. Not a machine, not technology, but an extraordinarily active interstellar body immersed in an extraordinarily volatile electromagnetic environment, generating emissions that merely resemble artificial signatures. And yet, a shadow of doubt remains. What if both things are true? What if 3I Atlas is somehow amplifying its own plasma output? What if it is intentionally provoking solar reactions, manipulating its environment to conceal deeper intentions? What if the alignment, the timing, the precision of the CME impact were not accidents at all, but part of a deliberate choreography? We are left with layers of possibility, each plausible, each consistent with fragments of data, none yet verified. Stefan Burns continues to watch. He has cast himself as the lone voice who saw this coming, the one who predicted solar activity, while others focused solely on composition and orbital mechanics. If his model holds, if further eruptions occur as 3C Atlas approaches and departs perihelion, his hypothesis will gain weight. What began as a fringe idea may start to sound less impossible, and the question of what 3 Atlas truly is will only grow more urgent. Meanwhile, the coronal mass ejection is already in flight. A billion-ton cloud of charged plasma racing through space at over 1 million kilometers per hour. Within days, it will reach the comet, still hidden behind the sun, and whatever happens there will unfold beyond our view. We can only watch the sun itself for new flares, new eruptions, new signs that the electromagnetic dialogue between star and visitor is continuing. When 3I Atlas re-emerges in November, we will look for the aftermath: changes in brightness, fragmentation, deviations from predicted motion, the fingerprints of impact. Behind the sun lies the perfect cover. Between October 21st and mid-November, the comet occupies a window of invisibility, a region of space no Earth-based telescope can penetrate. Anything could happen there, and we would never see it. This overlap of solar conjunction and perihelion is no trivial coincidence. The alignment is too precise, the timing too elegant. At the very moment the comet draws closest to the sun, moving fastest, under maximum thermal and gravitational stress, it is also completely hidden from every instrument on Earth. Harvard astrophysicist Avi Loeb posed the question that lingers over this entire sequence. Was this intentional? was this trajectory designed? In the careful language of orbital mechanics, he framed it as an engineering problem. If one wanted to perform a maneuver unseen, to alter course, deploy secondary bodies, or change configuration, the optimal time would indeed be perihelion during solar conjunction. It is the ultimate blind spot. And at that point, another principle becomes relevant: the Oberth effect. In astronautics, when you wish to change a spacecraft's orbit, you do not fire engines at random. You wait until velocity is at its peak, near the deepest point of a gravity well. There, a small impulse yields the greatest gain in kinetic energy. The faster you are moving, the more dramatic the result. For 3I Atlas, that moment, perihelion, is now approaching. On October 29th, 3I Atlas will be racing through space at roughly 68 kilometers per second relative to the Sun, the fastest velocity it will ever reach within our solar system. At that precise moment, any propulsive burn, if such a thing were to occur, would have maximum impact. If one intended to decelerate from interstellar speed and settle into a bound orbit around the Sun, this would be the perfect time to do it. If one wanted to adjust its path to intercept Earth at some later point, this would be when the maneuver should take place. If one planned to divide into multiple fragments following slightly divergent courses, this would be the optimal instant to trigger that separation, and all of it would unfold while the object remains invisible. Earth cannot see what happens there. Our telescopes routinely observe the Sun, but they cannot look directly into its blinding brilliance. The region known as the solar glare overwhelms any smaller object, burying it in light. Even if a telescope were oriented precisely along the correct vector, the Sun's luminosity would obliterate every trace of the comet's signal. For nearly 4 weeks, from mid-October through mid-November, 3Y Atlas is effectively invisible to every ground-based observatory on Earth. The solar illumination it receives at perihelion is staggering. With an estimated minimum diameter of 5 kilometers, 3Y Atlas will be struck by more than 33 gigawatts of solar energy across its surface. 33 gigawatts, the combined output of dozens of large terrestrial power stations, enough to energize entire cities. And all of that power will be absorbed by the comet's surface, heating it, driving sublimation, vaporizing ice, and potentially fueling processes we have yet to imagine. For a natural comet, such energy produces familiar results. Frozen ices vaporize into gas. Dust particles lift off. The coma expands, the tail lengthens. The brightness increases. All predictable, all charted in textbooks. But if anything more intricate lies beneath its crust, any internal mechanism, any structure capable of responding to heat in a non-natural way, 33 gigawatts would be more than enough to activate it. Enough to run engines. Enough to generate thrust. Enough to deploy secondary systems. Astrophysicist Avi Loeb notes that if 3I Atlas continues on a purely gravitational trajectory, we will know soon after perihelion. Its motion can be tracked, its brightness curve matched to prediction. Its closest approach to Earth on December 19th should occur precisely where the models expect it to be. The velocity, the timing, the apparent magnitude All will align with the natural comet hypothesis. But if anything deviates even slightly, if the arrival time differs by hours, if the orbital arc shifts by a fraction of a degree, if its luminosity fails to follow the expected curve, then we will know that something happened during those invisible weeks, something that altered its path, something not accounted for by gravity alone. In Loeb's essay, one phrase has captured global attention: alien technology masquerading as a natural comet. He does not present it as a claim, but as a hypothesis, a question worth considering given the precision and mystery of the circumstances. He even remarks that Halloween falls just 2 days after perihelion, a coincidence so poetic that it feels designed, the scariest day of the year, coinciding with the moment when an interstellar stranger, hidden behind the sun, may reveal its true nature. But if, for argument's sake, the object were artificial, why disguise it as a comet? Why the masquerade? The most logical answer is reconnaissance. If an advanced civilization wished to study a solar system undetected, it would not send a sleek metallic craft announcing its presence. It would send something plausible, something that fits within the host civilization's existing expectations. An interstellar comet provides perfect camouflage. It has a natural reason to be on a hyperbolic trajectory. It has a reason to approach the sun, to outgas, to shroud itself in a luminous coma that conceals whatever structure lies beneath. From afar, it would look exactly like what astronomers believe it to be. Only under close inspection, through spectroscopy or high-resolution imaging, would the inconsistencies appear. And if such an object were to perform any action that might betray its artificial nature, it would wait until it could not be seen. It would wait for solar conjunction. It would use the sun itself as cover. That is when you would adjust course, deploy instruments, or reconfigure systems, unseen, shielded by the sun's blinding veil. Then, as it emerges, it would resume its outward journey, leaving scientists to puzzle over tiny deviations long after the window for observation has passed. Too late to investigate, too late to confirm. Ambiguity preserved. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, will pass within 64 million kilometers of 3 von Asalos on November 4th. That is mere days after perihelion, when the comet begins to emerge from the solar glare, but before it becomes fully visible from Earth. JUICE carries cameras, spectrometers, and particle sensors. It was not designed to study comets, yet its instruments are more than capable of collecting data. If fragmentation occurred during perihelion, JUICE could detect the debris field. If the trajectory shifted, it could measure the new orbit. If the comet's emissions display unexpected features, JUICE could capture them. This will be humanity's first indirect glimpse of what transpired during the hidden window, a chance to determine whether 3I Atlas behaved like a comet or like something far stranger. The next key opportunity for observation will come in March 2026, when the National Aeronautics and Space Administration's Juno spacecraft passes within 54 million kilometers of 3 free Aegis near Jupiter's orbit. Juno carries ultraviolet spectrographs, infrared mappers, and microwave radiometers, a full suite of instruments capable of analyzing the comet's thermal emissions, composition, and any unexpected energy signatures. By then, 3I Atlas will have been under observation for several months. Astronomers will already have trajectory data from November and December, enough to know whether it followed the models precisely or deviated in some measurable way. Juno's readings will provide another crucial cross-check, a layer of verification independent from Earth-based observation, another dataset to compare against predictions. But the pivotal moment remains perihelion, October 29th, the point of maximum velocity and maximum solar stress. And we will not witness it directly. We will reconstruct it later, from the debris it leaves behind, from the brightness it displays as it reemerges, from the shape of its tail, from any divergence between its projected and actual path. We will infer its secrets from its silence. Avi Loeb has suggested that astronomers pay special attention in November and December, watching for any new objects that might appear near 3I Atlas, plural, not singular. The specificity of that phrasing is deliberate. If the comet is more than it appears, if it conceals smaller probes or payloads, then perihelion would be the ideal moment for deployment. The sun's tidal forces would provide the necessary separation energy, gently peeling the objects apart as they drift outward. By December, those bodies would have spread far enough along divergent paths to be distinguished as individual entities rather than fragments of debris. Should that occur, if telescopes detect multiple, coordinated objects emerging from a single point behind the sun, the natural comet hypothesis collapses. Of course, fragmentation remains a legitimate possibility. Comets can and do break apart when subjected to intense solar heating and gravitational stress. The combination of sublimation, gas pressure, and tidal forces can tear fragile material apart. Comet Shoemaker-Levy 9 famously shattered into 21 distinct pieces before colliding with Jupiter. Many others have disintegrated entirely during close solar passes, leaving nothing but transient dust clouds in their wake. If 3Y Atlas were to fragment naturally, the pattern would follow a familiar script, a linear string of objects tracing the same orbital path, drifting apart gradually, showing no signs of coordination or deliberate control. But if the separation were engineered, the signature would look different. The fragments would not form a tidy chain, but would diverge deliberately, each with its own vector and velocity, some larger, some smaller, perhaps exhibiting varied behaviors. That pattern, precise and intentional, would betray intelligent action rather than natural disintegration. December will be the testing ground for these theories. It is when the separation between any emerging bodies will be measurable, when independent observers across the world can triangulate their positions, track them over successive nights, and calculate their individual orbits. The date of December 19th, when 3I Atlas makes its closest approach to Earth, seems almost poetic in its precision. It is not an arbitrary moment. The timing falls during the long winter nights of the Northern Hemisphere, when skies are darker and clearer for extended periods. Amateur astronomers will have abundant observation windows, and the comet's position in Virgo, rising in the pre-dawn hours, will be ideally placed for telescopes in both hemispheres. If anything unusual is going to reveal itself, December is when the world will be watching. Loeb concludes his essay with a plea not for speculation, but for evidence. Let the data decide, he writes, not expectation, not fear, but measurement. The coming months will supply those measurements: brightness, spectrum, velocity, fragmentation. By the time Juno makes its pass in March, the story of 3I Atlas may already be written in numbers, yet the timing still haunts every analysis. Solar conjunction precisely overlapping with perihelion, the window of invisibility coinciding with the window of maximum solar energy. The perfect moment to act, unseen, untraceable. It is an arrangement so mathematically convenient that it feels engineered. Whether that perfection is coincidence or intent will determine how history interprets what happens next. If 3I Atlas emerges unaltered, same path, same composition, same predictable behavior, then this entire drama will dissolve into coincidence, a reminder of our tendency to see purpose in patterns. But if anything changes, if new objects appear, if its orbit shifts, if unexplained emissions flicker from its surface, then the coincidence becomes evidence. Evidence that the timing was not random, that the trajectory was calculated, that 3I Atlas knew exactly when to hide behind the sun, and what to do while the universe was looking away. The sun, it seems, has offered the perfect stage and the perfect cover. The question now is whether someone, or something, is using it. The so-called industrial alien alloy mystery has become one of the strangest twists in the story of 3I Atlas. The spectroscopic analysis should have been simple. You point a telescope at the comet, capture the light from its coma, break that light into a spectrum, and identify the elements by their emission lines. For every other comet in our solar system, the results follow a well-worn pattern: water vapor, carbon dioxide, trace metals such as sodium and iron, perhaps a little magnesium or nickel in tiny quantities. Nothing exotic, nothing that demands rewriting chemistry textbooks. But 3I Atlas refused to play by those rules. When the Keck 2 telescope atop Mauna Kea in Hawaii observed the comet on August 24th, it detected something nature was never supposed to make: nickel. And only nickel. Not trace amounts, but roughly 4 grams per second venting from the nucleus, without a single detectable atom of iron. That ratio is wrong, cosmically wrong. In every natural context ever studied, nickel and iron appear together. They are born together in the hearts of dying stars, fused side by side during supernova nucleosynthesis. They condense together in planetary disks, freeze together in meteorites, and behave almost identically in thermal and chemical processes. To find one without the other is like finding smoke without fire. It does not happen, except, apparently, in 3 Atlas. Avi Loeb did not soften his reaction when he reviewed the data. There is only one place we know of where that occurs, he said, and that is in industrially produced nickel alloys. He was referring to a specific compound, nickel tetracarbonyl, a molecule that forms when nickel bonds with carbon monoxide under tightly controlled conditions. Those conditions do not exist naturally in comets. They exist in factories. On Earth, this compound appears in refining plants and electroplating facilities, where it is used to purify or deposit nickel with extreme precision. It is a manufactured substance, a product of deliberate engineering. And according to Keck's data, 3I Atlas is producing it by the kilogram. Nickel tetracarbonyl plays a central role in the Mond process, a century-old industrial technique for obtaining ultra-pure nickel. You begin with impure ore, expose it to carbon monoxide at moderate temperatures. The nickel converts into a volatile gas, nickel tetracarbonyl, which separates from the contaminants. Reheat the gas, and it decomposes, leaving behind nearly perfect nickel metal. The process is elegant, efficient, and irreplaceable in high-tech manufacturing, particularly in aerospace applications, electronics, and components that must endure tremendous heat and stress. The aerospace connection is striking. Nickel-based superalloys are the backbone of rocket engines and spacecraft structures. They withstand the infernos of re-entry and the freezing cold of deep space. They are what we use when failure is not an option. And now, an interstellar object is emitting the very compound associated with those technologies. The implications are deeply unsettling. Either we are witnessing a natural process that astonishingly mimics advanced industrial chemistry, or we are watching a form of industrial chemistry unfold on an object that should be nothing more than ice and dust. The Keck team also noted another anomaly. The emissions of both nickel and cyanide around 3 High Atlas were asymmetric, stretching in both the solar and anti-solar directions. That configuration forms what astronomers call an anti-tail, a structure that appears to point toward the sun instead of away from it. Normally, solar radiation pressure blows a comet's tail outward. An anti-tail implies internal pressure, material being ejected from multiple sides, a sign of internal energy or even active mechanisms. Such behavior demands power, far more than ordinary sublimation could supply. The ratio of nickel to cyanide was not slightly above normal. It was orders of magnitude higher, hundreds or thousands of times the median for solar system comets. Cyanide itself is notable because it indicates carbon-nitrogen bonds, the building blocks of organic chemistry. When you combine organic molecules with industrial metals, you create a chemistry that feels almost hybrid. Biological precursors mingling with metallurgical byproducts. It is an unlikely combination, not impossible but profoundly strange. Researchers at Keck phrased their conclusion carefully. While they acknowledged the phenomenon was rare, they added that a new study suggests it could be natural. That single word, could, carries enormous weight. It does not mean the process is understood or even likely. It simply means scientists have not yet disproved every possible natural mechanism. In science, you eliminate the mundane before invoking the extraordinary. But when the mundane explanation requires inventing new chemistry never seen anywhere else, one must ask how far the boundaries of naturalism can stretch before they snap. The missing iron remains the most troubling clue. Iron is one of the universe's most abundant elements. It is the heart of planets, the core of asteroids, the skeleton of worlds. Every comet analyzed so far contains both iron and nickel, forged together long before the solar system formed. For 3Y Atlas, to show strong nickel emissions and no measurable iron suggests one of two things. Either a fantastically unlikely separation process during its birth, a region of space so peculiar that iron condensed out while nickel remained volatile, or, far more provocatively, active refinement, a mechanism that selectively releases nickel while withholding iron, a process that sorts elements with intent. If that process is natural, we have discovered a type of chemistry unknown to science. If it is not, then 3I Atlas may not be just a relic of cosmic dust, but the byproduct of deliberate engineering, a factory drifting between the stars. In industrial refining, separating nickel from iron is precisely the goal. The process isolates pure nickel by transforming it into a volatile compound that can be extracted from other metals. If 3I Atlas were not a comet, but a spacecraft, or some engineered object with nickel-based structural components or surface coatings, then the chemistry we are observing would make perfect sense. As the object approaches the sun, thermal stress could cause outgassing of nickel compounds. Carbon monoxide, necessary for forming nickel tetracarbonyl, might arise naturally from organic material on its surface or from the decomposition of more complex carbon-bearing molecules. The sun provides the heat. The reaction proceeds spontaneously once those conditions exist, and the result, seen from Earth, is exactly what Keck detected: abundant nickel, no iron, and a spectroscopic fingerprint identical to an industrial process. But the story deepens. In early October, the Very Large Telescope in Chile, equipped with its ultra-precise UVS spectrograph, gathered independent data that confirmed the anomalous nickel-to-iron ratio. It also noted that the presence of any metallic vapors in cometary spectra is, in itself, highly unusual. The surface temperatures of most comets are far too low for metals like iron and nickel to vaporize. These are refractory elements, meaning they have extremely high melting points. For them to sublimate, the comet would need to be far hotter than the models predict, or another mechanism altogether must be liberating those atoms. Several theories have been proposed. Collisional ejection, in which tiny grains strike one another and fracture, releasing metal atoms into the coma. Photolysis, in which ultraviolet radiation from the sun breaks down compounds containing metals. But neither process can explain the selective absence of iron. In every known natural setting, both elements are released together. The fact that 3I Atlas emits nickel with almost no accompanying iron points toward a selective mechanism, chothing, that favors nickel specifically. The so-called anti-tail adds another layer of intrigue. Normal comet tails point away from the sun, swept outward by solar wind and radiation pressure. But 3I Atlas displays a bright, structured stream of material extending toward the sun, visible in multiple wavelengths, including nickel and cyanide emissions. Researchers attempted to explain this as a geometric illusion, a perspective effect caused by large dust grains following ballistic arcs that, from Earth's vantage, appear to project sunward. But the data reveal that the anti-tail is not merely dust. It contains gases, molecules that should have been blown away, not pulled inward. That requires active jets. Material must be vented from the nucleus with enough velocity to resist solar pressure, at least for a time. And jets demand pressure, buildup, and release. Processes that imply subsurface reservoirs and mechanisms capable of directing outflow. Comets do sometimes behave that way naturally. Subsurface ice pockets heat rapidly, gas expands, and plumes erupt through cracks. Yet what makes 3I Atlas different is the coherence, the symmetry, the consistency across wavelengths. The pattern looks organized, not chaotic. Avi Loeb described the object as a comet that refuses to act like one, noting its trajectory, which is almost perfectly aligned with the plane of the planets, an orbit more deliberate than random. Insisting that 3I Atlas must be a comet, he wrote, is unwise, because it does not behave like one. He is not exaggerating. Optical images show a diffuse coma but no dramatic tail, no long stream of dust sweeping across the sky. For an object this massive, this close to the sun, and this visibly active, that absence is baffling. Instead of a classic cometary plume, there is a faint haze, ambiguous, unresolved, neither wholly comet nor wholly asteroid. The chemical evidence, however, is the sharpest anomaly. Nickel tetracarbonyl does not appear in nature. It is a human creation, a compound synthesized for a single purpose: refining and coating high-grade metals. Detecting it, or something spectroscopically indistinguishable from it, in the coma of an interstellar body leaves two possibilities. Either we have stumbled upon a previously unknown natural reaction that reproduces the signature of industrial chemistry with uncanny precision, or we are observing actual industrial chemistry taking place on an object masquerading as a comet. Ordinarily, scientists invoke Occam's razor, the principle that the simplest explanation is most likely. But in this case, the simplest explanation requires inventing an entirely new class of natural processes that just happen to mimic aerospace engineering. When the improbable becomes the only natural option, the razor begins to cut the other way. Scale deepens the mystery. 4 grams of nickel per second, sustained over weeks or months, equates tons of material. Where does it come from? How much nickel does the nucleus hold? A typical comet contains trace amounts of nickel locked within mineral grains, released slowly as its surface erodes. That would never yield kilograms of emission per second. The numbers imply either a far greater concentration of nickel than any known comet possesses, or a different source entirely. If 3I Atlas is natural, it is unlike any comet we have ever seen. If it is artificial, the data make sense. Nickel alloys are ideal for high-temperature structures, hull plating, thermal shielding, reinforcement frames. Under intense solar heating, such materials could release nickel compounds in significant quantities. The resulting signature, industrial chemistry glowing in the sunlight, would not be coincidence. It would be evidence of construction. The scientists analyzing this data are careful, cautious to the point of restraint. They are not declaring 3I Atlas artificial. They are documenting what they observe: the anomalous emission ratios, the missing iron, the industrial signature that should not be there. They acknowledge that natural explanations might exist, but they stop short of describing any concrete mechanism. No one has yet explained how a comet could produce a compound identical to those used in human nickel refining, or why it would do so without any sign of accompanying iron. That question remains unanswered. And in science, an unanswered question is not a dead end, but an invitation to theorize, to experiment, to challenge the boundaries of what we think nature can do. As 3C Atlas nears perihelion, the nickel emissions are expected to continue, perhaps even intensify, as solar heating reaches its peak. Both the European Space Agency's JUICE spacecraft and the National Aeronautics and Space Administration's Juno probe will soon bring their spectrometers to bear on the object, capturing higher resolution data over longer observation periods. These readings will tell us whether the strange nickel-to-iron ratio persists, whether it fluctuates with temperature, or whether new compounds begin to appear. Each spectrum will add another layer to the mystery, either narrowing the anomaly into something explainable or deepening it into something extraordinary. But for now, today, the evidence stands as it is based on what the Keck telescope and the Very Large Telescope have independently recorded. 3Phi 8 is releasing a chemical that should not exist in any comet, a compound synonymous with human metallurgy, a molecule found in aerospace manufacturing and high-temperature surface coatings, a compound that forms only under carefully controlled industrial conditions, or in the unlikeliest coincidence imaginable, somewhere far beyond our solar system. Unless, of course, what we are witnessing is the byproduct of a machine, the exhaust of a manufacturing process that took place light years away, now venting into our solar system as the structure heats and decays. The alternative, less sensational but no less astonishing, is that the universe is far stranger and more inventive than we ever imagined. That cometary chemistry is not limited to the patterns we know. That nickel tetracarbonyl can arise naturally through mechanisms we have yet to identify. That 3I Atlas represents an entirely new class of interstellar body, one that exhibits exotic composition and unprecedented thermal behavior. In that case, everything remains natural, just profoundly unexpected. Statistically, that is the safer bet. But it also asks us to accept a coincidence that borders on poetic absurdity, that nature, unaided, replicated a human industrial process molecule for molecule. With every new observation, that explanation feels a little harder to believe. Then, amid the scientific debate, an entirely different narrative began to spread, not from observatories, but from social media. A video surfaced and quickly went viral, claiming that on October 30th, 2025, at exactly 11:44 Universal Time, the world would experience something called the consciousness event. Not metaphorically, but literally. A planetary neurological synchronization triggered by cosmic forces. The video asserted that three phenomena would converge: the Sun at solar maximum, 3Y Atlas at perihelion, and Earth's magnetic field at its weakest point in decades. Together, these would amplify Earth's natural electromagnetic frequency, the Schumann resonance, to unprecedented levels, causing what the narrator described as a global awakening. The video was slick, cinematic, unnervingly persuasive. Its presenter spoke with quiet authority, blending scientific terminology with spiritual rhetoric. He described the Schumann resonance as Earth's heartbeat, oscillating at 7.83 Hertz, the frequency created by lightning discharges reverberating in the cavity between Earth's surface and the ionosphere. He pointed out that this same frequency overlaps with human theta brainwaves, the rhythms of deep meditation, creativity, and altered consciousness. The implication was powerful, that human minds are quite literally tuned to the same frequency as the planet itself. Then came the prediction. the trigger. On October 30th, the narrator said, three cosmic forces would align. The Sun, blazing at its most volatile in 20 years, Earth, magnetically vulnerable, and 3I Atlas, the interstellar visitor, passing through perihelion at the exact moment of peak solar resonance. According to him, the result would not be metaphorical enlightenment, but a measurable electromagnetic transformation sweeping across the species. Solar flares, coronal mass ejections, magnetic fluctuations, all of it woven together into a single apocalyptic equation. According to the viral theory, three cosmic events are about to collide. First, the Sun, entering its most violent phase in 2 decades, at the height of solar maximum, a period defined by eruptions of plasma, flares, and electromagnetic storms. Second, 3Y Atlas, a city-sized interstellar object reaching its closest approach to the Sun, heating, glowing, releasing gases, and interacting with the solar wind in ways that still defy our models. Third, Earth's magnetic field, weakened to its lowest point in the current cycle, stretched thin and vulnerable. Normally, this field acts as a planetary shield, deflecting charged particles and cosmic radiation. But right now, it is more permeable, more fragile, more open to influence. When these three forces converge, the video claims, the Earth's natural frequency, the Schumann resonance, will surge tenfold. Instead of the usual 7.83 hertz, the planet will hum at 70 or even 80 hertz, broadcasting a global electromagnetic pulse straight into the human brain. And the brain, they insist, cannot resist. It will entrain. The narrator delivers it like a revelation. Entrainment, he explains, is not mysticism. It is neuroscience. When exposed to a powerful external rhythm, neural oscillations align with it. Your brainwaves lock on, synchronizing automatically, no matter your will or belief. Once the planetary field surges, your consciousness will shift. Not metaphorically, physiologically. Your neurons will begin to fire in rhythm with the amplified resonance of the planet itself. The speaker's numbers are as hypnotic as his tone. He cites a global coherence threshold. The square root of 1% of the human population is the minimum required to initiate planetary change. For 8 billion people, that would be 90,000 minds resonating in unison. But with this electromagnetic surge, he claims, 2 billion will synchronize spontaneously, more than 20,000 times the threshold for critical mass. The result, he says, will be a cascading resonance field enveloping the entire species, drawing more and more people into coherence until synchronization becomes self-sustaining. He then moves into the brainwave breakdown. Normal waking consciousness operates in the beta range, about 20 hertz, the realm of planning, reasoning, and alert focus. But during this event, the Earth's frequency spike will push human brains into gamma states from 40 hertz up to 100 or even 200. Gamma waves, he explains, are associated with heightened awareness, deep unity, and expanded cognition, the frequencies monks reach after decades of meditation. On October 30th, he insists, 6 billion people, roughly 76% of humanity, will experience those states simultaneously, willingly or not. The statistics pile up like prophecy. Of those billions, the video claims, 365 million possess heightened electromagnetic sensitivity. Individuals who already feel headaches or emotional changes during solar storms. For them, the effect will be strongest. And of those, 43 million will reportedly reach full transcendence, ego dissolution, unity consciousness, mystical enlightenment. Experiences that throughout history were confined to monasteries, mountaintops, and private revelation, suddenly democratized, broadcast to millions at once. The precise moment of transformation is given. October 30th, 2025, 11:44, Universal Time. That, the narrator insists, is the instant when 3I Atlas hits perihelion, when the electromagnetic geometry is perfect, when the Sun, comet, and Earth form a single resonant alignment. The predicted window lasts 12 hours, from 6 in the morning to 6 in the evening Universal Time. During that period, the video says, the Schumann resonance will spike, solar activity will peak, and Earth's magnetic field will fluctuate wildly. 12 hours of exposure to frequencies the human brain has never endured before. But the story does not end with enlightenment. The speaker issues a warning. Technology will suffer. Global positioning systems could fail for 12 hours or more. Power grids may falter. Communications could degrade. Satellites, computers, and electrical systems all could be disrupted by the same electromagnetic forces said to elevate human consciousness. It is almost as if, the narrator muses, the universe itself is telling us to disconnect from our devices and reconnect with ourselves. The preparation guide is both spiritual and practical. Begin meditating daily, even for 10 minutes, to accustom your brain to fluctuating frequencies. Spend time outdoors to ground your electromagnetic body. Keep food, water, and essentials ready, just in case the networks go dark. The tone balances reassurance with warning. Calm instruction wrapped in cosmic urgency. It tells viewers they can prepare, but also that failure to do so could make the experience overwhelming. Billions of people entering altered states simultaneously could mean global peace or mass confusion. The science behind the claims, as skeptics quickly pointed out, is only half real. The Schumann resonance does exist. Brainwave entrainment is a documented effect. Solar flares can disturb Earth's magnetic field, but linking those facts to a planet-wide synchronization of consciousness requires leaps of logic, vast, poetic, and unsupported. There is no evidence that increasing the Schumann resonance, even by an order of magnitude, could synchronize billions of brains or ignite a global awakening. Yet the idea, once planted, continues to spread. A modern myth in the language of physics, promising that the next solar storm might not destroy us, but unite us. There is no known mechanism by which the Phi Atlas, a comet more than 200 million kilometers from Earth, could directly influence our planet's electromagnetic field in the manner described. The prediction that 43 million people will simultaneously experience transcendence has no foundation in any peer-reviewed research. Yet, the idea has found an audience. The viral video spreading this prophecy has drawn millions of views, filling comment sections with an electric mix of anticipation, skepticism, personal testimony, and outright awe. Some viewers claim they already feel energy shifts, heightened intuition, vivid, almost prophetic dreams. Others dismiss it entirely, branding it pseudoscience designed to prey on humanity's collective anxiety about solar storms and mysterious interstellar visitors. Still, a surprising number take it seriously. They meditate daily, gather in online groups, stockpile supplies, and mark their calendars for October 30th, waiting with a strange blend of hope and apprehension. The connection to 3Y Atlas is central. The video presents the comet as a catalyst, not the cause, but an essential piece of a cosmic alignment. It describes the interstellar object as a carrier of its own electromagnetic signature, an outsider whose passage through the sun's magnetic field amplifies the Earth's frequencies. Whether this interaction is natural or deliberate remains unclear. The video never states outright that the comet is artificial or that alien intelligence is involved. Yet it implies significance, treating the object not as mere rock and ice, but as a participant in something vast, even spiritual. It casts 3I Atlas as a messenger, a bridge between cosmic phenomena and the evolution of human awareness. This narrative has deep roots. Long before astronomy stripped away mysticism, comets were symbols of divine communication, omens foretelling the fall of empires, the birth of prophets, or the dawn of new eras. They appeared suddenly, uninvited, and vanished just as quickly, leaving wonder and fear in their wake. Modern science reduced them to celestial leftovers, frozen relics from planetary formation, harmless wanderers obeying physics alone. But that symbolic weight never truly disappeared. When a comet from another star system streaks across the sky, behaving oddly, arriving in an age of social unrest, technological dependence, and spiritual hunger, old instincts awaken. Humanity starts to look upward again, searching for meaning in the motion of the heavens. The October 30th prophecy, unlike ancient superstition, is at least testable. It makes measurable claims. Either the electromagnetic surge occurs, or it does not. Either satellites fail, power grids fluctuate, and global positioning systems collapse, or the day passes uneventfully. Either millions report altered consciousness, or the silence of ordinary life prevails. By November 1st, there will be data. Observatories will have logged solar output. Magnetometers will have tracked field variations. Psychologists will record patterns in mass behavior. One way or another, the claim will stand or fall. Yet the more intriguing dimension of this phenomenon may not be electromagnetic at all, but psychological. Even if no measurable change occurs in the planet's magnetic field or in the Schumann resonance, the expectation of transformation might still generate its own kind of synchrony. Tens of millions of people collectively fixating on the same hour, watching the sky, waiting for revelation. That shared focus is itself a form of resonance. Not electrical, but cognitive. Not physical, but social. Belief has always had power. When enough minds anticipate the same event, they unconsciously align their perceptions, interpreting coincidences as evidence, dreams as signs, coincidences as cosmic proof. The result can feel collective, a wave of meaning sweeping across the species, even if the cause lies entirely within the human mind. The video ends with conviction. October 30th, 2025, the narrator declares, will be remembered as the day humanity evolved, not slowly, not biologically, but consciously, together in a single moment. It is a promise wrapped in science-flavored mysticism, bold enough to attract millions, fragile enough to shatter under scrutiny. Within weeks, it will be either vindicated or forgotten. Yet in the meantime, it has done something remarkable. It has woven Three-Eye Atlas into humanity's mythology. It has turned an astronomical anomaly into a spiritual countdown. 45 days to prepare, the narrator says. 45 days until everything changes. Whether that transformation is electromagnetic or imagined, real or symbolic, it has already begun. In the minds of those who look to the sky not for data, but for destiny. The Schumann resonance, measured faithfully since the 1960s, may not spike at all. But belief, as always, vibrates at its own unmeasurable frequency. The Schumann resonance, Earth's natural electromagnetic heartbeat, has remained remarkably stable for decades. It fluctuates slightly with solar activity, atmospheric conditions, and lightning distribution. But the baseline frequency hovers around 7.83 Hertz. Minor oscillations are normal. Tenfold surges are not. In the entire history of geophysical monitoring, no such spike has ever been recorded. If, on October 30th, that frequency were to jump to 70 or 80 Hertz, it would mark a scientific first, an event that would demand immediate investigation. And if that unprecedented surge happened to coincide prebitally with Three-Eye Atlas reaching perihelion, aphelion, the alignment would be too extraordinary to ignore. Every geomagnetic observatory on Earth constantly tracks fluctuations in the planet's magnetic field, their instruments feeding real-time data to public databases. The same is true of solar observatories, monitoring coronal mass ejections, solar flares, and the flow of charged particles in the solar wind. Space weather forecasting is routine, and the records are transparent. Anyone with an internet connection can verify what happens on October 30th, whether it is an ordinary day in the heliosphere or something far stranger. That is the rare virtue of this consciousness hypothesis. It is falsifiable. It makes specific, measurable predictions. In a world overflowing with mystical claims that dissolve under scrutiny, there is something almost refreshing about a theory that can, at least in principle, be proven wrong. But what if it is not? What if the predictions hold true? What if on October 30th, systems begin to falter? Satellites lose signal lock, power grids flicker, communications sputter, and millions of people report altered states of awareness? How would we explain it? Would we blame solar storms, magnetic fluctuations, coincidence? Or would we finally consider the possibility that 3B Atlas, an interstellar visitor glowing near the sun, is interacting with more than light and gravity? That its electromagnetic signature, whether natural or engineered, is influencing systems we thought were immune? The consciousness shift theory is easy to dismiss because it straddles two worlds that rarely mix, science and mysticism. It blends empirical terminology with metaphysical aspiration, making even open-minded academics uneasy. Yet dismissal is not debunking. Until the date passes, until the data arrives, the idea remains a possibility, however improbable, however unsettling, that a comet from another star might act as a catalyst for something larger than physics, something that touches the collective mind itself. But speculation aside, what can we say for certain? What is documented, measured, peer-reviewed, published? Even stripped of any spiritual framing or talk of alien intent, 3I Atlas remains a scientific enigma. It exhibits a pattern of behaviors that no other interstellar object has shown. 8 distinct anomalies, each remarkable on its own, together forming a constellation of improbabilities that defy easy categorization. Anomaly 1, ecliptic alignment. 3I Atlas moves within 5 degrees of the ecliptic plane, the flat disk where all major planets orbit the Sun. Statistically, this should not happen. Interstellar space is three-dimensional. Objects can arrive from any direction. The odds of one entering so neatly along the solar system's orbital plane are less than 1%, perhaps a fraction of that, depending on how the probabilities are modeled. By comparison, our 2 previous interstellar visitors, Oumuamua and Borisov, approached at steep inclinations, one at 123 degrees, the other at 44. They cut diagonally through the solar system like skipping stones. 3I Atlas, by contrast, glides almost perfectly flat, as though intentionally positioned to intersect planetary orbits, a trajectory that increases opportunities for observation from Earth, Mars, and beyond. Anomaly 2, the antitail. Comet tails, by definition, point away from the Sun. Solar radiation and the solar wind push gas and dust outward, sculpting the familiar luminous arc. But 3A Atlas breaks that rule. It displays a structure extending toward the Sun, a sunward emission visible across multiple wavelengths. The official explanation invokes large dust particles, heavy enough to resist radiation pressure, following ballistic paths that, from our viewpoint, appear reversed. Yet this requires improbably precise ejection speeds, perfectly aligned angles, and a persistent internal mechanism to maintain symmetry. Natural comets can vent jets, but they are brief and chaotic. 3I Atlas shows something else: sustained, balanced, almost engineered coherence. Anomaly 3, scale. Estimates place its diameter between 5 and 20 kilometers, depending on albedo assumptions. Oumuamua measured mere hundreds of meters, Borisov perhaps 2 or 3 kilometers. By any standard, 3I Atlas is immense, the largest interstellar object yet observed. That size alone is improbable. Massive bodies are rare, difficult to eject from their home systems, and harder still to accelerate to interstellar velocities. To detect such a giant as only our 3rd visitor strains probability. Either we have been extraordinarily lucky, or large interstellar objects are far more common than models predict, or, more provocatively, the object's size is intentional. If 3 Archaeatalis were a constructed craft, its bulk would make sense. Ample volume for shielding equipment or propulsion systems designed for million-year journeys. Anomaly 4, planetary flyby trajectory. Its path through the solar system is anything but random. 3I Atlas passes near Mars, Venus, and Jupiter, each encounter close enough for spacecraft stationed at those worlds to collect data. For a natural object, such a sequence borders on impossible. Most interstellar visitors follow hyperbolic arcs that cross the sun's domain once and depart forever, interacting with, at most, a single planet by chance. Yet this one threads the needle, weaving through the inner system in a route that conveniently maximizes observational coverage from multiple vantage points. The coincidence is remarkable. Or perhaps coincidence is not the right word. Each of these anomalies, considered separately, could perhaps be explained through natural variability, chance alignment, or incomplete understanding. But all 8, as researchers will soon outline, converge on a single, disquieting reality: that 3I Atlas behaves less like a drifting relic and more like something designed with purpose. The consciousness theories may belong to the realm of speculation, but the data, the geometry, the chemistry, the physics tell a quieter, equally haunting story. Whatever this object is, it is not ordinary. A reconnaissance trajectory. That is how it appears. A path through the inner solar system so precise it seems designed to gather data on multiple worlds in a single pass. Anomaly 5. Nickel enrichment. The nickel-to-iron ratio in 3I Atlas is not just off, it is radically skewed. Orders of magnitude higher than any comet ever studied. The discovery of nickel tetracarbonyl, or a compound spectroscopically identical to it, introduces the uncomfortable question of industrial chemistry. Natural processes capable of concentrating nickel while simultaneously suppressing iron are vanishingly rare and require tightly defined physical conditions. The fact that this is happening in an interstellar object, whose composition should reflect the general elemental ratios of its birth environment, is deeply unsettling. Either 3I Atlas formed in a system with bizarrely anomalous chemistry, or something within it is selectively releasing nickel. One plausible mechanism is thermal degradation, the heating and breakdown of nickel-based alloys as the object nears the sun. Anomaly 6, water content. Most comets are roughly 80% water ice. 3I Atlas is about 4. The vast majority of its volatile content is carbon dioxide, frozen dry ice, with comparatively little water vapor detected. That makes it an outlier even among solar system comets, and extraordinarily unusual for an interstellar one. This ratio implies an origin in a region so cold and distant that carbon dioxide could condense, while water, paradoxically, remained too volatile to survive. Alternatively, it could mean the comet has lost its water over eons of cosmic travel, stripped away by interstellar radiation, micrometeoroid impacts, or repeated heating during stellar flybys. Either scenario points to extreme age or a complex history. An object with such composition could be billions of years older than the solar system itself, or it could have spent millennia shedding its volatiles during a long, wandering journey between stars. Anomaly 7. Extreme negative polarization. When light scatters off dust or ice, it becomes polarized, its waves aligned in a specific direction. The degree and orientation of that polarization reveal the nature of the particles reflecting it. 3I Atlas, however, exhibits negative polarization values, deeper and more pronounced than any comet on record. Even Borisov, our previous interstellar visitor, did not display anything close to this. Such extreme negative polarization suggests dust grains with highly unusual properties, possibly metallic, crystalline, or compacted structures capable of scattering light in ways that ordinary porous comet dust cannot. Once again, the evidence points toward material that is not random or primitive, but organized, processed, perhaps even engineered. Anomaly 8. Arrival Direction. 3I Atlas entered our solar system from within 9 degrees of the sky region that produced the legendary WOW signal, the strongest candidate for an extraterrestrial radio transmission ever detected. In 1977, astronomer Jerry Eman recorded that signal, a narrow-band 72-second pulse at a frequency often associated with deliberate communication. It was never repeated, never explained. Its origin was traced to the constellation Sagittarius, near the Milky Way's center. And now, decades later, an interstellar object arrives from almost the same direction. The coincidence might be exactly that, coincidence. Sagittarius is a vast region filled with countless stars and molecular clouds. Yet the alignment is eerie. If, hypothetically, an advanced civilization transmitted a signal in 1907 and then dispatched a physical probe decades earlier, both would arrive from roughly the same area of the sky. The timing would be close, though not exact. The mathematics do not perfectly align unless the probe departed long before the signal. Still, the symbolism is striking. The most famous unexplained signal from space, and the most anomalous interstellar visitor humanity has ever encountered, both linked by direction, both stirring the same question. These 8 anomalies do not prove that 3I Atlas is artificial. Each can, on its own, be rationalized. The ecliptic alignment might be improbable, but not impossible. The anti-tail could result from complex gas dynamics. The enormous size may reflect detection bias. Larger objects are simply easier to spot. The planetary flybys could be chance. The nickel enrichment might trace back to exotic but natural chemistry. The low water fraction could arise from formation in an extremely cold region. The negative polarization might just mean the dust grains are denser or metallic. And the alignment with the WOW signal could be statistical happenstance. Sagittarius is, after all, a crowded field. Individually, every anomaly can be explained away, but taken together, they resist dismissal. The improbabilities stack, each one multiplying the next, until the cumulative odds strain the boundaries of coincidence. This is what researchers refer to as the cumulative improbability problem. When too many low-probability events converge in one system, the natural explanations start to feel less natural. To address this, Avi Loeb proposed what he calls the Loeb scale, a framework for evaluating the likelihood that a celestial object is of technological origin. The scale runs from 1 to 10. 1 signifies full consistency with natural phenomena. 10 represents unmistakable evidence of artificial construction. On that spectrum, 3I Atlas currently ranks a 4, anomalous but not conclusive. It occupies a gray zone, too strange to ignore, not strange enough to confirm. A ranking of 4 carries weight. It means watch closely. It means collect more data. It means do not leap to conclusions, but do not look away either. And it is precisely that ranking that explains the extraordinary global response. the activation of the International Asteroid Warning Network, the coordinated observation campaign, and the sudden silent vigilance of every major observatory on Earth. The activation of the International Asteroid Warning Network marked a turning point. Coordinated observation campaigns were set in motion across continents. Resources were mobilized. Telescopes from Chile to Mauna Kea, from the Canary Islands to Australia, were assigned to track one enigmatic object through December and beyond. A ranking of 1 or 2 on the Loeb scale would never have justified this. Such low scores mean routine monitoring, nothing extraordinary. A ranking of 8 or 9, on the other hand, would have sparked a very different response. Classified briefings, military consultation, emergency protocols. But 4? 4 is the equilibrium point, just high enough to stir attention, just uncertain enough to keep panic at bay, intriguing enough to warrant priority time on the world's most powerful instruments, yet ambiguous enough to preserve public calm. Every new observation has the potential to nudge 3i Atlas up or down that fragile scale. If JUICE detects additional anomalies in November, if amateur astronomers capture strange structural details in December, if Juno registers emissions inconsistent with natural cometary activity in March, the ranking climbs. Conversely, if its motion remains purely gravitational, if the chemistry resolves into known reactions, if the light curves settle into predictable patterns, the ranking drops. The Loeb scale is not dogma. It's fluid, responsive to evidence. And right now, evidence is still being gathered. But consider the threshold. If even one more major anomaly is confirmed, if the rumored Fermi gamma-ray detection proves real, if the alleged engine-like acoustic data from ground sensors is validated, or if the upcoming coronal mass ejection produces a response inconsistent with normal cometary physics, 3i Atlas would move to a 5 or 6. At that point, everything changes. Media attention would erupt. Funding for observation would multiply. The artificial hypothesis would no longer belong to fringe circles. It would enter mainstream scientific debate. The anomalies are not isolated curiosities. They reinforce each other. The ecliptic alignment amplifies the improbability of its planetary flybys. The nickel enrichment, paired with the antitail, implies internal processes beyond sublimation. The low water content and extreme negative polarization both suggest unique material properties, metallic, crystalline, structured. And that arrival vector from Sagittarius, so eerily close to the direction of the old WOW signal, becomes far more evocative when stacked atop the rest. You cannot disassemble these anomalies and assess them separately. Together, they form a pattern. And in science, pattern is everything. The faint outline of a signal emerging from noise. There's a quiet integrity in keeping 3i Atlas at a 4. It's an admission of mystery without surrendering to speculation. It's science at its most disciplined. We don't know yet. It's an acknowledgement that the evidence is incomplete, that conclusions must wait for the next wave of data. But this honesty creates a vacuum. And in that vacuum, imagination expands. Theories breed, forums erupt. People fill the silence with conjecture, prophecy, fear, and wonder. The 8 anomalies are not rumors. They are documented measurements. Data from Keck, from the VLT, from independent observatories across the globe. Data has no preference. It does not conspire or embellish. It merely reflects what is. And what it reflects, when examined as a whole, challenges the limits of what we thought interstellar nature could do. Whether this challenge leads to revised cometary physics or the first recognition of extraterrestrial technology is the question now unfolding, night by night, in observatories around the world. Now, the waiting nears its end. After the long invisibility of solar conjunction, after perihelion's unseen passage, after weeks of debate and speculation, we are entering the window where answers begin to arrive. The timeline, November 4th, ESA's JUICE spacecraft will pass within 64 million kilometers of 3I Atlas and direct its instruments toward the object. Mid-November, the comet reemerges from behind the sun, visible once again to ground-based telescopes. Late November, the official IA Abdul N observation campaign begins. December 19th, closest approach to Earth at roughly 269 million kilometers. During this entire period, hundreds of instruments, professional and amateur alike, will record every motion, every flicker, every spectral fluctuation. JUICE, the Jupiter Icy Moons Explorer, was never meant for this role. Designed to study Europa, Ganymede, and Callisto, it launched in 2023 and has spent years executing complex gravity assist maneuvers around Earth and Venus to build up speed for its eventual arrival at Jupiter. Yet by cosmic coincidence, on November 4th, 2025, it will find itself in the perfect position. A bystander in deep space with an unobstructed view of an interstellar enigma. Its instrument suite is formidable. Janus, a high-resolution visible light camera, can capture detailed morphology of the comet's coma and any fragmentary debris. Magius, the infrared spectrometer, can identify chemical composition and temperature gradients. SWAY, the sub-millimeter wave instrument, can detect trace gases and isotopic ratios. Together, they can map 3I Atlas in unprecedented detail. If fragmentation occurred during perihelion, Janus will see the debris. If its chemistry changed, Imagus will confirm it. If new emissions appear, SWI will record their spectra. And because JUICE observes from a different vantage point than Earth, it can reveal aspects our ground-based instruments might miss. Subtle motion, thermal plumes, faint outgassing jets, hidden by solar glare. Timing is everything. JUICE will observe just days after perihelion, when the aftermath is still unfolding, when heat signatures linger and mechanical effects remain visible. If the comet experienced violent outgassing, the coma will still be bright and expanded. If it released structures or fragments, they will not yet have drifted far. If its trajectory changed, the deviation will be measurable. JUICE is perfectly placed to catch 3I Atlas in that crucial transitional state, the moment when secrets are closest to the surface. But there is a catch. The data won't reach Earth quickly. The spacecraft, now on the far side of the sun, relies on its medium-gain antenna for communication. The high-gain dish is being used as a heat shield to protect against solar radiation. Transmission rates are painfully slow, and the signal must travel hundreds of millions of kilometers. The European Space Agency has already confirmed that JUICE's 3I Atlas data will not arrive until February 2026, a 3-month delay between observation and revelation. 3 months of waiting, 3 months of speculation, 3 months of solace, while the world wonders what JUICE saw when it turned its eyes toward an object that should not exist, moving through our system like a question from another star. Deep space communication is a negotiation between power, distance, and geometry. Every bit transmitted must fight against vast emptiness. JUICE, like all spacecraft, operates under strict bandwidth constraints. Its power is finite. Its antennas can point in only one direction at a time. The mission's priority is Jupiter and its moons, not an interstellar comet wandering through the inner system. So, the 3I Atlas data becomes a secondary payload, queued, compressed, and transmitted only when the primary telemetry allows. By the time those packets reach Earth, are decoded, verified, and processed, months will have passed. And when the public release finally happens, Earth-based telescopes will already have gathered their own troves of data for comparison. That ground campaign begins in mid-November. 3 Afra Atlas will rise from the sun's glare, a faint smudge in the pre-dawn sky. At first, it will hang low on the horizon, dim and elusive. But as the geometry of observation improves, its brightness will increase. By late November, when the International Asteroid Warning Network officially launches its observation campaign, the comet will be within reach of major observatories. High-sensitivity instruments will lock onto it nightly, mapping its brightness curve, measuring its spectrum, tracking every subtle shift in motion. December will bring the amateurs. Tens of thousands of sky watchers with 8-inch telescopes or larger. This is where the distributed observation network becomes decisive. Space agencies and national observatories control their data. Images curated, results peer-reviewed, releases timed for precision and narrative clarity. But amateurs answer to no one. They upload raw frames within hours, share spectra, compare notes across continents, build mosaics of the comet's evolving structure. If 3I Atlas behaves unexpectedly, if it brightens too fast, splits into fragments, or drifts from its predicted path, they will be the first to see it, and their findings will spread online long before any agency confirms or denies them. The IAWN's design anticipates this. Its closed registration workshops ensure that participants follow uniform procedures. Observers collect standardized astrometric data, the position of the comet measured with exquisite precision. These measurements can detect even minute deviations from a purely gravitational orbit. They can reveal non-gravitational forces, outgassing jets, or the subtle recoil from mass loss. In essence, the IAWN campaign is planetary surveillance, a global, coordinated watch over a single visitor whose nature remains uncertain. The culmination comes on December 19th, closest approach to Earth, roughly 269 million kilometers away. 3I Atlas will not grace the naked eye, but small telescopes will capture it easily, glowing faintly against the stars. On that day, it should reach maximum brightness according to current models. Any departure from that curve will be telling. If the comet shines brighter than expected, It could signal increased activity, fragmentation, or hidden surface area. If it dims, it could mean a denser, less volatile nucleus, something more solid, perhaps more engineered, than ice and dust. That date also offers the best opportunity for parallax. When observatories across the globe measure the comet's position simultaneously, the slight differences in its apparent location can pinpoint distance and speed with extraordinary accuracy. If those measurements diverge from predictions, it will confirm that the orbit has shifted, evidence of some unseen event during perihelion. Then comes the deeper question: fragmentation, or something more deliberate? The mothership hypothesis suggests that 3I Atlas might not be a single body at all, but a carrier, releasing smaller probes during perihelion when solar energy peaks. If this occurred, multiple discrete objects should appear in late November and December, not chaotic debris clouds, but individual bodies moving on separate, purposeful paths. The sun's tidal forces would gradually separate them, making them distinguishable by December. Amateur networks would spot this first. Several bright points where only one should be, each with its own trajectory, each moving just differently enough to betray intention. Natural fragmentation leaves disorder, uneven spacing, irregular shapes, chaotic motion. But coordinated release would look patterned, symmetrical, controlled. Avi Loeb described the image poetically. 3I Atlas, as a cosmic dandelion scattering its seeds into the solar wind. Each seed, he suggested, could be a probe, a mini explorer designed to investigate separate worlds or phenomena, released at the moment of greatest solar energy. It is speculation, yes, but speculation with boundaries. It is testable. If secondary objects appear and behave independently, if they target different sectors of the solar system, the hypothesis gains substance. If nothing appears, if 3I Atlas remains solitary and predictable, then nature reclaims the explanation. Because, after all, comets do fragment. They always have. The universe does not need intention to create beauty or mystery, but this time we will have eyes everywhere to find out which kind of mystery we are truly witnessing. Fragmentation, in itself, is not a mystery. It is a natural process, driven by thermal stress and the slow violence of sunlight. Heat causes cracks. Cracks propagate. The nucleus splits. We have watched it happen countless times. Shoemaker Levy 9 broke apart into 21 fragments before slamming into Jupiter in 1994. Other comets have disintegrated entirely, vanishing into trails of dust. So, if 3I Atlas fragments, that alone proves nothing unusual, unless the fragments behave in ways no natural debris should, unless they accelerate, unless they hold formation, unless their motion violates the cold precision of Newtonian mechanics. December is when all of that will be tested, when prediction meets observation. One of the most debated claims came from the so-called whistleblower that by December, home-based observers will see it all. And that test is now imminent. As 3I Atlas becomes visible to amateur telescopes, thousands of people will point cameras and spectrographs toward the same patch of sky. They will upload frames within hours. If anomalies appear, secondary objects, controlled movements, structured formations, they will not remain secret. If nothing happens, If the comet behaves as comets always do, the claim collapses. This prediction is binary. Either the sky changes or it doesn't. Then comes the gamma ray question. The alleged Fermi detection, if genuine, would be revolutionary. Natural comets do not emit gamma rays. Those high-energy photons require violent particle acceleration, the kind seen in pulsars, black holes, or nuclear reactions. If 3I Atlas is producing them, the emission should persist or even intensify during its most active phase. Fermi data is public. Anyone can access it, cross-check light curves, and see if a persistent source aligns with the comet's coordinates. If that correlation holds, it becomes part of the official record. The conversation changes instantly, because gamma emission would demand a mechanism, and none of our known cometary models can provide one without invoking something new, something we have yet to imagine. The November-December window will also reveal whether the October 21st coronal mass ejection, the CME that physicist Stephen Burns predicted, actually struck 3Y Atlas and left an imprint. When a CME slams into a comet, it can rip off its ion tail, trigger a burst of fluorescence, or momentarily expose the nucleus beneath. We have seen this before. In some cases, comets brighten suddenly as compressed gases ignite in ultraviolet light. In others, the magnetic field wraps around the coma like a wave, tearing the tail away entirely. If any of those effects occur in sync with Burns's forecast, his electromagnetic interaction model gains powerful credibility. The IAWN campaign ensures that every one of these phenomena will be captured. Running until January 27th, it provides 2 months of coordinated monitoring after closest approach, 2 months to watch for late fragmentation, delayed brightening, subtle shifts in orbital parameters. Not all cometary reactions are immediate. Outgassing can continue long after perihelion. Structural weaknesses can take weeks to evolve into full breakups. By extending coverage well into the new year, the network guarantees that even slow-developing anomalies will not escape detection. And then comes the closeout teleconference, February 3rd, 2026. Representatives from observatories around the world will gather virtually to compare data, reconcile measurements, and compile a unified report. On the surface, it will sound like any other scientific review: astrometric precision, photometric consistency, spectroscopic results. But beneath the technical vocabulary lies a single unspoken question. Did anything impossible happen? If the answer is yes, if measurable deviations persist that cannot be reconciled with natural models, then that meeting will mark the moment the astronomical community officially acknowledges that 3I Atlas is more than just a comet. The public, however, will not wait for February. The internet ensures transparency and chaos. By December, astronomy forums, social media feeds, and live-streamed telescope networks will be alive with data, images, and speculation. This distributed observation is both a strength and a liability. A strength because no central agency can filter or suppress what people see with their own equipment. A liability because misinformation travels as fast as truth. An overexposed image, a compression artifact, a stray cosmic ray on a CCD sensor, all can become viral proof within hours. Sorting genuine signal from digital noise will become an exercise in collective discernment. From November through January, humanity will be watching together. Scientists, hobbyists, believers, skeptics, each seeking answers to the same question that has hovered since July. What exactly is this thing? Is 3I Atlas merely a natural comet with peculiar chemistry and improbable geometry, an artifact of cosmic variance that just happens to test the limits of our models? Or is it something else? An emissary, a construct, a message moving through physics instead of language? Did something occur during the hidden days of perihelion when no eyes could see it? Did its trajectory shift by fractions of a degree, whispering of maneuver? Did its emissions flare with patterns that suggest control rather than chaos? Soon we will know. Data will come from every continent, from backyard telescopes and billion-dollar observatories alike. More information than we have ever collected on any interstellar visitor. Enough to answer, finally, whether 3I Atlas is an accident of nature or the first undeniable sign that we are not alone. And from that flood of data, patterns will begin to surface, faint at first, then undeniable. Patterns that could either dissolve into noise, dismissed as statistical artifacts, or crystallize into something impossible to ignore. Patterns that suggest we are witnessing a phenomenon beyond precedent, something that may redefine humanity's place in the universe, something that whispers, "We were never alone." Since the dawn of astronomy, one question has haunted the human mind: where is everyone? Physicist Enrico Fermi first voiced it over lunch in 1950. A deceptively simple question that has become one of the deepest paradoxes in science, the Fermi paradox. If the universe is vast, ancient, and brimming with galaxies, if billions of stars host planets in habitable zones, then where are all the others? Why no signals, no probes, no unmistakable signs of intelligent life? Why does the night sky blaze with silence? Over the decades, scientists have offered countless answers. Maybe intelligent life is rare, an evolutionary accident that almost never repeats. Maybe civilizations tend to self-destruct before they can reach the stars. Perhaps they exist, but communication across interstellar distances is impractical. The signal's too weak, the timescale's too long. Or maybe we simply haven't been listening properly, tuned to the wrong frequencies, staring at the wrong corners of the sky. But there is another possibility, darker and far more unsettling. A hypothesis that transforms the cosmos from a vast wilderness of possibilities into something far more dangerous. The dark forest hypothesis. The term comes from Liu Cixin's 2008 novel, The Dark Forest, a philosophical sequel to The Three-Body Problem. In Liu's vision, the universe is a forest at night. Every civilization is a hunter moving alalely between the trees, unable to see the others, but knowing they are out there. The forest is full of predators. You cannot know who is benign and who is lethal. The only rational strategy, if survival is your goal, is silence. Never reveal your position. Because the instant you speak, you announce yourself to all the unseen hunters. In that vision, the universe is not empty because life is rare. It is silent because making noise is suicidal. Every civilization that dares to broadcast risks extermination by those who hear and preemptively strike. Those who stay quiet survive. Those who shout are erased. The galaxy becomes a cemetery of silences, filled with ghosts of those who spoke too loudly. And if that is true, if the cosmos really is a dark forest, then humanity has already made a catastrophic mistake. For over a century, we have been transmitting radio signals that spill out into interstellar space. Television, radar, satellite beacons, an electromagnetic fingerprint expanding at the speed of light. We have even sent deliberate messages to nearby star systems, attempts at cosmic introduction. If Leo's metaphor reflects reality, then we have done the one thing every survivor avoids. We have called out in the dark. How does this connect to 3I Atlas? Harvard astrophysicist Avi Loeb and his colleagues have explored exactly that in a paper provocatively titled, "Is the Interstellar Object 3I Atlas Alien Technology?" The paper does not claim certainty. It is a thought experiment, an exercise in caution. But it asks the question few dare to confront. What if 3I Atlas is not friendly? What if it is reconnaissance? The authors consider the dark forest scenario explicitly. What if an advanced civilization, following the logic of cosmic survival, detected our radio emissions long ago and dispatched a probe, not to make contact, but to evaluate whether we pose a threat? A silent observer, mapping our system, gathering data, unseen until now. Loeb is careful. The tone is not sensational but methodical. This is not evidence of hostility, he writes. But if the dark forest model holds, we must consider that reconnaissance precedes strategy. The reasoning begins with the trajectory. 3I Atlas travels within 5 degrees of the ecliptic plane, the flat disk where all major planets orbit. That alignment is highly improbable for a random interstellar object. Space is three-dimensional. Trajectories should arrive from all angles. Statistically, fewer than 1 in 100 interstellar comets would naturally align this closely. For comparison, Oumuamua entered at an inclination of 123 degrees, slicing steeply through the solar plane. 2I Borisov arrived at 44 degrees, still tilted relative to planetary orbits. 3I Atlas, however, comes in nearly flat, as if intentionally plotted to intersect the paths of multiple worlds. Its flight path supports that suspicion. The object passes close to Mars, Venus, and Jupiter, not in abstract astronomical terms, but close enough that a hypothetical spacecraft could collect detailed environmental readings, magnetic fields, atmospheric spectra, even radio leakage from each world. The precision of that sequence resembles a reconnaissance tour, a deliberate threading through the heart of the inner solar system. And then there's the timing. 3I Atlas reaches perihelion, its closest point to the Sun, on October 29, 2025. By tracing its path backward through space, Loeb's team estimates it would have crossed the solar system's outer boundary nearly 8,000 years ago. That number is chillingly specific. 8 millennia, roughly the span of recorded human civilization. It means that if this object was sent intentionally, it arrived in our cosmic neighborhood precisely when humanity was learning to write, build cities, and light the first beacons of technology. Coincidence? Possibly. But it raises a haunting question. If we are now detecting it at the exact moment our technology becomes advanced enough to study it properly, then perhaps this was the plan. to wait until the natives could look up and see. 1,000 explanations remain on the table. It could be a comet, a fragment, a natural body obeying nothing but gravity and chemistry. Or it could be something older and more deliberate, a probe drifting through the solar wind, following a strategy conceived in another sun's shadow. Because in a dark forest, the smartest hunter never walks in blindly. He sends a scout first. That moment, roughly 8,000 years ago, marks the dawn of human civilization, when we shifted from nomadic tribes to farmers, builders, and dreamers. It was when we carved the first symbols into clay, raised the first cities from dust, and ignited the first fires that could be seen from the stars. Was that timing a coincidence? Perhaps. The universe, after all, is indifferent to human calendars. But if you were an advanced civilization monitoring nearby stars for signs of emerging intelligence, 8,000 years would be more than enough time to send a probe. Long enough for it to arrive just as the fledgling species began reaching for the heavens, just as it built the technology capable of detecting such a visitor, just as it became, finally, interesting. That brings us back to the Oberth maneuver, a key to the dark forest scenario. 3I Atlas reaches solar conjunction on October 21st and perihelion on October 29th. During those days, it vanishes from Earth's view, hidden behind the blinding disk of the sun. It is then, at maximum velocity, that the object sits in the perfect position to perform a trajectory change using minimal energy. If it wished to slow down, to linger, it could. A small but deliberate thrust at perihelion would be enough to shed interstellar speed and capture itself into a bound orbit around the sun. The question is, why would it want to stay? If 3I Atlas were a reconnaissance probe, its mission might still be underway. Perhaps it needs more time to observe, to record, to transmit. Perhaps it is waiting to gauge our reaction to its presence. Or, in the more unsettling version of the hypothesis, it might be preparing for the next stage of its task: deployment of secondary systems, activation of long-dormant components, actions that require stability rather than escape. Loeb's paper explores this possibility with meticulous caution. The calculations show that if the object experienced a non-gravitational acceleration of roughly 5.9, 10 to 5 AU per day to, normalized to 1 astronomical unit, it could alter its course to intersect Earth, not immediately, but between late November and early December 2025, exactly when the global IAWN observation campaign will be scrutinizing it. That prediction is testable. If 3I Atlas changes its orbit during perihelion, we will know in November, when it reemerges from solar conjunction. Its position and velocity will betray the maneuver. Should those changes curve toward Earth, we would have confirmation that the object is under intelligent control, and we would have precious little time to decide what to do. The analysis goes further. Another possibility arises: a Jupiter intercept. On March 16, 2026, 3I Atlas is projected to pass within 54 million kilometers of the gas giant. Such a close approach could allow it to use Jupiter's immense gravity for a slingshot maneuver, either redirecting itself deeper into the inner solar system or accelerating outward at greater speed. The energy required for this adjustment lies within the range of natural cometary outgassing, making the effect ambiguous. It could appear perfectly natural, even if it were not. That ambiguity is what makes this the nightmare scenario. A probe built to look like a comet. A machine designed with plausible deniability, capable of thrusting in ways indistinguishable from sublimation jets. Its every motion shielded behind the alibi of physics. It could maneuver freely, while remaining scientifically natural until the moment it chose not to be. It could observe, transmit, and then either depart silently or begin a secondary mission based on what it learned about us. Yet Loeb and his colleagues are not alarmists. They emphasize that the simplest explanation remains the most probable. 3I Atlas is likely a natural interstellar comet. No panic, no certainty, only curiosity. They argue for preparedness, for disciplined skepticism, for considering the artificial hypothesis not as conclusion, but as contingency. Because if we dismiss the possibility outright and it turns out to be true, the consequences would be catastrophic. Still, the counter-argument stands. Why would a civilization capable of interstellar travel use such a primitive delivery system? Why send a slow, centuries-old relic when faster, more advanced methods surely exist? Why expose it to scrutiny by skimming so close to multiple planets? Why make it interesting? The answer, perhaps, is economy. Interstellar travel consumes staggering energy. Even a civilization thousands of years ahead might favor efficiency over speed, stealth over spectacle. A small, patient probe could drift between stars like a seed on the cosmic wind, waiting millennia for the right moment to awaken. Its patience measured not in decades, but in epochs. And if that is what 3I Atlas is, then its long silence was not indifference. It was strategy. Even for an advanced civilization, accelerating a probe to even a fraction of light speed would require staggering amounts of energy. Perhaps this, slow, deliberate, patient travel, is simply the most efficient strategy. Send countless probes, let them drift between stars for millennia. And by the time they arrive, each one captures a civilization frozen at a precise moment in its evolution. If humanity had launched a probe to Alpha Centauri at the dawn of our calendar, it would only now be arriving. The images it returned would show our species transformed beyond recognition, a snapshot of 20 centuries of progress, faith, and folly. To those who think on cosmic timescales, waiting 8,000 years is no delay at all. It is precision timing. Another explanation lies in stealth. If your purpose is to study, without alarming the subjects, you hide in plain sight. You send your machine cloaked as a natural body, its surface venting like a comet, its trajectory mimicking celestial randomness. A perfect disguise for an observer among primitives who barely understand the sky. The principle is simple. We already practice it ourselves. Biometric drones shaped like birds, surveillance devices camouflaged as stones, sensors disguised as coral on the ocean floor, observation through imitation. And in the vacuum of space, the perfect camouflage is to appear as ice and dust. In a universe where civilizations may destroy anything unfamiliar, the safest probe is one that looks like a harmless rock. Which leads to a more sobering thought. Even if we confirm tomorrow that 3i Atlas is artificial, what exactly could we do about it? Launch a mission to intercept? The object is hurtling through space at over 200,000 kilometers per hour. No current technology could catch it. By the time we developed the engines and the funding, the probe would be gone. Its mission complete, its report transmitted, its next destination already chosen. Humanity, for all its pride, remains a spectator in its own solar system. We are not the hunters in this cosmic forest. We are the watched, perhaps the catalogued. And if Liu Cixin's dark forest hypothesis is even partly correct, if the galaxy teems with civilizations that assess, rank, and eliminate potential threats, then we have already been noticed. For a century, we have been shouting into the dark. Every broadcast tower, every radar pulse, every microwave link between satellites is a flare against the cosmic night. We are noisy, radiant, and vulnerable. And perhaps 3i Atlas is the first quiet response. Loeb's paper closes not with panic, but with precision. It urges vigilance. More data, more observations, more science. If the object behaves exactly as a natural comet should, fragmenting at perihelion, fading along its expected light curve, obeying only gravity, then the artificial hypothesis dies with the data. But if it deviates, even subtly, if it accelerates without physical cause, if it fragments into symmetrical components or alters its course, then we must face the possibility that this visitor is not a coincidence, that it is evidence. The implications are terrifying. For decades, the search for extraterrestrial intelligence has been built on optimism, the assumption that contact would be enlightenment, not extinction. We have listened for signals, built vast arrays, imagined peaceful meetings beneath alien suns. But what if contact is the one thing we should never desire? What if the silence of the universe is not indifference, but self-preservation? The more we learn, the clearer the logic becomes. In a dark forest filled with unseen hunters, those who speak perish first. If that is true, then 3y Atlas may not be an emissary of friendship. It could be a surveyor, an examiner, a sentinel dispatched to assess whether the noise coming from the blue planet warrants attention or removal. Its report, traveling at the speed of light toward whatever sent it, might decide humanity's fate. We might soon discover what happens to species that grow too loud, too visible, too confident. We may finally understand why the galaxy seems empty, not because it is lifeless, but because everything that once called out has already been silenced. This, of course, remains speculation, the farthest edge of reason and fear. Yet it is rooted in logic, in survival dynamics, in the cold equations of game theory. It is the kind of possibility that demands humility, not hysteria. Because if the dark forest is real, ignorance offers no safety. 3i Atlas could be just another comet, a frozen wanderer passing through the light of our sun. Or it could be a test, an examination humanity did not know it was taking, the results of which will determine whether our story continues or ends as a footnote in someone else's survey of extinct civilizations. We will know soon enough. The observation window opens in November, and when it does, the universe may finally answer the oldest question we have ever asked. The data will arrive soon, and when it does, the universe may no longer be a distant abstraction. We will see whether 3i Atlas behaves like an ordinary comet, or whether it does something that forces us to confront the unthinkable, that we are being observed, and perhaps have been for far longer than we realize. 60 days stand between us and the moment of truth. In that short span, all the theories, suspicions, and calculations converge on one date, December 19th, 2025, the day of closest approach. On that morning, telescopes across Earth will aim at the same point in the sky. Amateur astronomers will fill social media with fresh images. Professional observatories will gather terabytes of precision data. It will be the day the mystery becomes measurable. If the object's motion remains purely gravitational, the debate will begin to quiet. If not, if its path, brightness, or structure deviate from predictions, then the implications will ripple far beyond astronomy. In 60 days, we will know enough to decide whether this is coincidence or contact. Perhaps not with final certainty. Science seldom offers that, but with the clarity of evidence. We will see if it fragmented like ice under heat, or endured intact like metal. We will see if new emissions, strange spectral lines, or secondary objects appear. And we will see whether the silence of space agencies can survive the weight of undeniable data. Understanding the timeline is essential. Today is October 22nd. 3i Atlas is still hidden behind the sun, lost in the glare, racing toward perihelion at 68 kilometers per second. In 7 days, on October 29th, it reaches its closest distance from the sun, 203 million kilometers, just inside Mars's orbit. This is the moment of greatest heat and stress, when ice should boil away and dust burst outward in bright jets. It is also, if the object possesses any form of propulsion, the ideal moment to alter course. For several weeks after perihelion, it remains invisible from Earth, moving through the blinding inner solar system. Then, on November 4th, a unique opportunity arises. ESA's JUICE spacecraft, Jupiter Icy Moon's Explorer, will pass within 64 million kilometers of 3i Atlas. JUICE was never meant for this. It was built to study Jupiter's moons, yet the geometry of space has placed it at the perfect vantage point. ESA confirmed that the spacecraft will turn its cameras and spectrometers toward the interstellar visitor for a brief observation window. This will be humanity's first post-perihelion look at 3i Atlas, the first chance to see whether it brightened, broke apart, or began to behave in ways nature cannot explain. JUICE's instruments, JANUS for imaging, MAJAS for infrared spectra, SETI for sub-millimeter gas detection, could reveal the composition and structure of the coma, the presence of metallic vapors, or even the telltale symmetry of engineered design. Because the probe's perspective differs from Earth's, it may glimpse asymmetries invisible to ground-based telescopes. Yet there is a catch. At this stage of its orbit, JUICE is near the sun and forced to use its high-gain antenna as a heat shield, communicating instead through a smaller medium-gain system with painfully slow data rates. The spacecraft is also on the far side of the sun from Earth, meaning limited transmission windows and long signal delays. ESA has already stated that full data downlink will not occur until February 2026, 4 months after the flyby. That delay is logical yet maddening. If JUICE records something extraordinary, we will not know in time to act. By February, 3I Atlas will have swept past Earth, beyond Jupiter, and into the outer system, unreachable and unrepeatable. Unless, of course, the analysis is performed quietly, in real time, behind closed doors, classified long before the public release. While the world waits for that hidden data, the story continues from Earth. In late November, 3I Atlas will emerge from the sun's glare into the pre-dawn sky. Its return to visibility will trigger the long-prepared IAE Beyond observation campaign, officially beginning November 27th. Every night for 2 months, observatories across the globe, large and small, will record its brightness, motion, and spectrum. Coordinated through workshops and secure channels, the campaign's observers have been trained to collect standardized astrometric data, to identify even the tiniest deviations that might signal non-gravitational forces. 3I Atlas will glide through Virgo, faint at first, then brightening as it climbs higher in the morning sky. By mid-December, amateurs with modest telescopes will be able to track it, contributing their images to a growing global archive. On December 19th, it makes its closest pass, 269 million kilometers from Earth, faint but reachable, a ghost sweeping across the dawn. That is the culmination of everything. Years of speculation, months of debate, weeks of preparation. On that day, the data becomes truth. If nothing unusual appears, the story will fade into history, a curiosity, a lesson in scientific restraint. But if the anomalies persist, if the object behaves like no comet ever observed, then December 19th will be remembered as the day humanity looked up and realized the sky was not empty. It was watching back. This is the moment the sky becomes democratic. 3I Atlas will reach a magnitude of roughly 12 to 13, far too faint for the naked eye, invisible even through binoculars, yet easily within reach of the thousands of amateur astronomers around the world, equipped with 8-inch telescopes and patience. These observers are not bound by institutional protocols or bureaucratic embargoes. They do not wait for clearance or press releases. Within hours of capturing an image, they will upload it online, analyze it, share coordinates, compare trajectories. Every data point becomes communal. Every pixel becomes a piece of the truth. This is what makes December different. The whistleblower was right when they said that December would reveal everything, not because the object will necessarily behave dramatically, but because the sheer number of eyes watching ensures that no anomaly, however subtle, can be hidden. You cannot censor the night sky. You cannot embargo the curiosity of thousands of independent observers. December 19th, the day of closest approach, is the fulcrum. At 1/8 astronomical units, 269 million kilometers, 3I Atlas will still be safely distant over 700 times farther than the Moon. There is no threat, only opportunity. It will be close enough for high-resolution spectroscopy, close enough for sensitive instruments to resolve the nucleus from its glowing coma, close enough to search for clues that might separate the natural from the impossible. And this is what we must look for. First, the trajectory. Has it deviated even slightly from the path defined by purely gravitational mechanics? A fractional shift, a deviation of a few arcs, seconds, could reveal unseen forces, outgassing perhaps, or propulsion. Second, the spectrum. Are those strange nickel emissions still there? Does the iron remain missing? Does the carbon dioxide to water ratio still defy cometary norms? Do new molecular lines appear, whispering of processes we cannot yet name? Third, the morphology. How does the coma behave? Is it symmetrical or warped, smooth or filamented? Do jets of material emanate from fixed coordinates, or do they drift, pulse, and fade in rhythmic cycles? And fourth, companions. Are there fragments? Natural comets fracture under heat and stress. The tidal forces of the sun tear at their cores, and debris trails often follow their paths. We should expect to see this. Chunks, shards, dust, expanding into space like the petals of a dying flower. If that happens, the natural hypothesis holds. The object is a comet, albeit an unusual one. Its strange chemistry can be explained, its improbabilities reduced to statistics. Humanity will breathe easier. But if it remains whole, if it passes through the inferno of perihelion unbroken, unscarred, unmelting, that is another matter. Very few comets survive such close encounters intact, especially those wandering in from the interstellar deep for the first time. Survival without fragmentation implies a strength beyond gravity and ice. It implies structure, something engineered, something bound by design. After the December campaign comes one last chapter. The Jupiter flyby, March 16th, 2026. On that date, 3I Atlas will pass within 54 million kilometers of the gas giant, and NASA's Juno spacecraft will have front-row seats. Juno's ultraviolet spectrograph, infrared mapper, microwave radiometer, all instruments built to probe Jupiter's atmosphere, can pivot to capture this transient visitor. It will be the closest view of 3I Atlas we may ever achieve from a spacecraft. If anomalies persist by then, if Juno detects metallic vapors, structured light curves, or synchronized emissions, the implications will no longer be academic. This will be the final data point before the object slips away forever, before it returns to the dark, leaving only a trail of numbers and questions behind. Whether comet or construct, the truth of 3I Atlas will unfold not in secret laboratories, but under open skies, through the shared lenses of humanity's watchers. For once, the cosmos answers not to governments or agencies, but to the collective gaze of those who simply refused to stop looking. If 3I Atlas is going to surprise us, if it intends to maneuver, deploy secondary payloads, or finally show what it really is, then the Jupiter flyby is the natural stage for revelation. It will be far enough from the sun for clean telemetry, close enough to Jupiter's gravity well to exploit orbital mechanics, and squarely in the field of view of NASA's instruments. Yet, again, the clock works against us. Juno's data will take weeks to transmit, months to decode and analyze. By the time the images and spectra reach Earth, the object will already be speeding outward, beyond Jupiter, slipping back into the darkness between worlds. The moment for action, if any existed, will be gone. This is the curse of astronomy. We are always studying the past. Light needs time to cross the void. Signals crawl through the deep space network. By the time we understand what we have witnessed, the universe has already turned the page. 3I Atlas is passing through our neighborhood right now, and we are racing against time to record every photon before it vanishes. In a few short years, it could be nothing more than a dim, retreating ember, out of reach, out of sight, leaving us only the fragments of data we managed to collect in this fleeting encounter. Unless, of course, it doesn't leave. Unless something happened during those unobserved weeks behind the sun. If the object slowed, if the hypothesized Oberth maneuver took place, it could have bled off enough velocity to remain trapped by the sun's gravity. In that case, 3I Atlas would stay with us, circling the inner system in a long elliptical orbit, returning every few decades for renewed study. That possibility has not been excluded. Only once it reemerges in November will astronomers be able to calculate its post-perihelion trajectory. If its velocity is lower than models predict, if its path has shifted inward toward a solar capture, then we will have confirmation that something occurred, something powerful enough to change the destiny of an interstellar body. What that means would demand global scrutiny. Yet another thread in this story refuses to die, the so-called consciousness shift theory. Viral videos insist that on October 30th at 11:44 UT, a cosmic alignment between the Sun, Earth, and 3I Atlas will amplify the planet's electromagnetic resonance, synchronizing billions of human minds in a moment of awakening. They speak of Schumann frequencies multiplied tenfold, of collapsing technology and unified thought. It is a compelling myth, cinematic even, but it collapses under the weight of physics. The described mechanisms do not correspond to any known electromagnetic interaction with the brain, and the proof offered online dissolves under scrutiny. Still, it reveals something profound. Humanity's yearning for meaning, for transcendence in the face of the unknown. People want this object to be more than ice and rock. They want it to be a sign, a catalyst, a bridge between the cosmic and the spiritual. That impulse is ancient and deeply human, but it cannot replace evidence. If 3I Atlas exerts any measurable influence on Earth, the instruments will register it. Magnetometers, radio arrays, particle detectors. The data will either confirm or deny the extraordinary. And if nothing appears, the consciousness shift prophecy will fade into history beside every failed doomsday and unfulfilled revelation. So where does that leave us now, with an interstellar object exhibiting confirmed anomalies, with planetary defense protocols quietly active, with a whistleblower alleging intercepted signals, with peer-reviewed papers daring to ask whether we are witnessing technology, not geology? And above all, with a countdown, 60 days until the observation window, 60 days until we know whether this was merely another visitor from the stars or a message written in motion across the solar sky. Whatever the truth, it will not stay hidden much longer.